Okay. Yesterday we did spend a good chunk of time, like almost 2 hours talking about S3. But yeah, we did discover a lot of interesting details. And right from brainstorming to the deep dive of actual architecture, we did quite a bit of fancy things. Now coming back to the main agenda for this week, it has to be around high throughput systems. Now high throughput systems where there comes in storage engines, there comes in processing pipelines and whatnot. Right. So what we'll be focusing on today is we'll be going through LSM trees and just understanding the kind of Lego blocks that would help you make those design decisions, like the kind of constraints that we're playing with and why would we pick A versus B, right? And basically just assuming that we don't know what LSM tree is, we have never read it, but just out of the constraints that we are playing by, how would we optimize or how would we build the actual tree or the actual data structure there? So this is what we'll be doing first, and then we'll be building a video processing pipeline for YouTube and just a couple of other important problems with YouTube. Okay. So we'll start with LSM trees. Last week we went through Bitcast. So we know that Bitcast was really fast, right? Because it did append only logs and in-memory keys and all. So it did well. It did very well. But now what do we want to do is what do we want to do? Our problem statement is simple. Bitcast was fast, but we want to go a little faster. Okay. So what would we do? That's what would build a foundation for LSM trees. Okay. So Bitcast pe the two underlying principles of Bitcast were append only files and in-memory index. Okay. We have to go a little faster. But what would we do? What made Bitcast fast? It was basically the append only file. So the files were always open in append only mode, which means very high write throughput because your disk does not have to do seeks while writing it. Or basically random writes nahi hai. Right? And to make gets faster, it had an in-memory index, so lookups become almost order one. Okay, assuming that hash table is order one. Okay. So now what we want to do is we want to better that.
Batch the writes.
Batch the writes. What? So you'll be clubbing writes where?
While writing to disk. We have a buffer writer. Have a bigger buffer writer when you are writing to disk.
Hmm. So you would be buffering all the writes in memory and then flushing it once every few minutes onto disk.
Yes.
Right. So through this, what you are doing is effectively you are
Quality.
not writing it on disk every time. So that's where you are saving time.
Yes.
Right? Okay. Any other thing that you can do in general? This question goes for everybody. Okay. Did everyone understand what Varun was trying to optimize? So Varun said that instead of writing it onto disk every time, this is very similar optimization which we applied during distributed ID generators as well, where instead of writing IDs every time onto disk, we applied that if my counter mod 1000 is equal to 0, basically once every 1000 times, and then only you will write it to the disk. This is very simple. This is very similar to that. So the main bottleneck, but not really bottleneck, but main concern here is that what makes this slow? See, you have an in-memory index or lookup at that one disk, वहाँ पे you can't do anything else. What you can definitely do is when you are writing it, the main, but the thing that would hog the performance would be the append only part. So basically writing to the disk part, right? So what if you don't write to the disk at all and you write in memory? That's what the core idea behind LSM trees is. Okay, so instead of writing to the disk, we write to memory. Now, what would happen if we do this, what kind of things are we getting out? The advantages and disadvantages.
Possible data loss.
Data loss. Data loss is a massive disadvantage. Now, what would we do to handle that?
Yeah, right ahead.
Rep- replicate.
First option is solution would be replication. So what would you replicate and how would you replicate?
Right hand log, maybe immediately data comes, do the commit log kind of.
Okay, basically right head logging is what you're okay. So basically by replicate you mean writing it onto disk, but then
The purpose.
isn't that very similar to Bitcast?
No, we replicate to another node or another place.
Replicate to another node. Okay, replicate to another node. But when you say another node, it means you will be doing a network IO, which is even slower than disk.
Yeah.
Right? So you can't do that. So Amrish said, what about we write it on commit log? Did everyone understand what commit log is? So every operation you get, you also write to a disk. But my counter question is, if you are already writing it to the disk, then how is it solving the problem? How is it making it faster than Bitcast?
So I just wanted to make one point. I'm not very sure. There is something in Linux called as a TMPFS file system. So that carves out a space in the RAM itself, which will be as a kept until and unless you delete that file system.
No, commit log here it's append only, right? So
Yeah.
it will be very fast. So
But then it is very similar to Bitcast then.
yeah, it would be, but with that in memory. So if you want to present into certain format into this, not doing immediately, just do in memory, and whatever structure you want to dump, do it in once that, just like.
But then how is it faster than Bitcast? Or in general, if you are adding, because now all of your write operations, you are not only writing it to the disk similar to what we did with Bitcast, but you're also writing it into an in-memory thing because you're batching the writes. So instead of doing just one operation, you are making one more operation on top of that. So then something has to be better than Bitcast. So what were the limitations of Bitcast? Like even by doing this couple of writes, like one on memory, one on commit log, we are still getting enough benefit to move to this kind of storage system. Basically making Bitcast better per se. What was the limitation of Bitcast? What was that one limitation of Bitcast?
I mean, memory constraints.
Memory constraints, because all the keys were to be stored in memory, right? Because on where it sits onto the disk, where basically where the value lies is held in an in-memory hash table, right? So if we want to make instead of, now we were talking about basically making faster Bitcast, but then we realized if we make faster Bitcast, which means instead of writing it to the disk, we write it to memory. So then we are having data loss ka problem. If you are having data loss ka problem, a possible solution to this is like replicating it to another node, but it is even worse because replicating it to another node matlab network call, right? Another solution was to do commit log. Commit log implying every single write operation will be first flushed down onto a file. But it is very similar to what Bitcast already does. So, which means that we cannot make Bitcast faster without having having a fear of losing our data. If we are losing, if we fear losing, if we don't want to lose out on our data, we would be doing, or we would have to write it to a commit log. So then we can't make bitcast faster, but what we can definitely make is bitcast better. Right. So now the constraint. So with this two things that we discussed till now, bitcast and the way to make it faster, there is only one thing that was the limitation of bitcast, was that all the keys should be stored, or we should be able to hold all the keys in memory, so that it points that okay, this key is stored, the value for this key is stored in this location in this file. So given that, in order to make bitcast better, all we have to do is like by adding those two writes, one in memory, one on disk, if we can somehow get rid of that limitation.
So we can
Then-
segment that, right?
Hmm.
So memory gets, because once that memory size, just like mem tables we do, right? So mem table, once this size is fixed, then pass it to disk and create a new mem table. And though that limitation of keeping everything in memory will be solved by that if we just fix the size of mem table.
Okay. So basically we have to remove the limitation of all keys to be stored in memory. So one solution that Amrish gave was to have mem tables. What are mem tables, Amrish?
Mem tables is kind of a form of binary tree which is arranged in sorted order. You insert whenever it comes, it will be added into the mem table. Once size goes off after certain thing, then it will be dumped in just like log structured SS table kind of. So it will be dumped to the disk. But whenever you have to read, then you have to read so many SS tables. Like those keys will not be present in current mem table. So you have to load that deserialized LSM table in form of mem table, then you access it. That way you can do that. But
Okay.
that part, like keeping whole keys in memory, you can avoid.
Okay, great thing. So what we would do here is, although Amrish put up a lot of fancy words for folks who don't know, we would be walking through this exact solution. We would start from zero and we would reach to this solution, and then we would find ways to optimize it. So one thing to note really closely here is this is exactly how databases are pitched. Like there are a couple of databases in the market, and you just find a small wedge. Here, this database does this better, but this is its limitation. The other database gives us feature ABC, but this is limitation. Can I create a database that fits in this wedge? Like this small thing. So basically Bitcast was very fast, but it was suffering from this one limitation, which was like keys to be there in memory. So can there be another database or a data structure or a storage engine that would better this, that would get rid of that thing? It might add another constraint in the process, but it should be able to solve this problem, right? So this is exactly how databases are pitched. So while I was working at Amazon, what happened was like we were trying to build storage engines, some sort of storage solution, and this is the exact drill that we went through. So we pulled out list of all the storage engines that Amazon had for its internal usage, and we found okay, this is low throughput, sorry, low throughput, low cost, high access solution. Basically the one that I was working on, low throughput, which means you cannot make a lot of queries on that. Low access, or basically slower access, because data was stored on S3, but it was cheap. So money was the distinguishing factor. So we were getting very high cost advantage, but we were losing out on access in this, right? There was another database which was like really high throughput, not so optimized on cost, very high throughput, very high access cost, or low access times, very high throughput. So this was another database which was there. So we tried to create another database that would fit in between two. And then we pitched that product, and then we got approved, and then we started building it. Right. So that when we were doing this sort of analysis for all the internal databases, and that is how we identified, okay, this particular space is empty, and there is a need for a database that would solve this kind of problem. So then we used to then start architecting it. In the real world, this is the exact step that is taken when someone open sources their databases on GitHub, or when someone tries to think to build a database on GitHub, they just try to optimize for, or they just try to find a space where they can wedge in their database. This is exactly what happens in real life. So what we would do is we would now go through the journey of like making Bitcast better by eliminating that limitation, and in the process understand LSMPs. Yes, Piyush?
Arpit, what sort of scenarios, like where exactly do you use Bitcast? Like I'm not very about
Bitcast
that.
is something, so basically Bitcast is an embedded database. Wherever you would find a need of using an embedded database, you can just Bitcast. So places, possible places where you need embedded database, it depends on the kind of architecture you have. Number one. Number two, if you were Uber uses it to store its production grade data of riders and drivers and the transportation platform on React. React is a distributed Bitcast sort of database. So React gives that benefit. So React is basically sharded Bitcast. Right. So depending on the kind of, because at the end Bitcast also supports what? Key value store. If you only need key value store like thing, but with a very high write throughput, that's when you would use Bitcast. But Bitcast is an embedded database. So everything has to be there in one node, but that is not a scalable design. So that is where the concept of Bitcast is then encapsulated, or it is basically encapsulated by Riak. RIAK is the name of the database, which would basically make Bitcast sharded and distributed across multiple nodes. Right. So this is how you would gain high write throughput and scale at the same time, just for like one key value use case.
Samjha.
Okay.
So,
Yeah,
Arpit, isn't Redis, if we enable AOF append only file, it's doing the same thing, right?
very similar, but Redis internally has a lot of complex data structures.
Yeah,
so what would happen is, if you do that, the overhead of maintaining the data structures might become a disadvantage when you have a very high write throughput system.
Yeah.
Right. That's the only concern. So here what Amrish told was, what if we simply use Redis and we just say that every single write that goes to Redis is also written onto the disk, right? Something similar to that. So if we have that, it is something but Bitcast, because Redis is also a key value store. But remember when we were discussing this about caching and cache eviction algorithms and all, where I was talking about the random cache eviction algorithm did almost equal, the performance was near equal as compared to LFU or LRU. The same thing, because overhead of data structures, because when you are using the data structures, it might need to flush the corresponding data structures onto disk, and then loading the data structure, creating a copy in memory when loading the file will be an overhead. Right? So these are like, it seems like a very minor concern to us, but when we are operating similar things at scale, this becomes the deal breaker or the deal maker. Right? Key, what kind of benefits, or are we even able to support this kind of throughput or not?
So basically, problem is though Redis does this. So if you want, let's say node crashes and then it has to recover. So because it's a maintaining,
थोड़ा सा heavy हो जाता है, and plus every write, it's not supposed to operate the way, but basically Redis's primary use case is to serve from in memory.
Yeah.
Right. It would not give you persistence by default. You are just using the commit log sort of functionality of Redis to just ensure that you are not having data loss.
Yeah. So you have to enable that by default.
You have to enable that, yeah. Okay. Sure.
So
Now
once off the topic question, I read somewhere that it's a Redis is single threaded, but is still able to handle the 65K. Request per second kind of. So it's because being in memory, and they use something what you call select socket level select, and what you call polling.
I'm not I'm not that deep into this Redis internal, but I would definitely want to do that. So not to comment, but yeah, we can definitely discuss it post the session if you want. We'll just basically scroll through the internet together.
Uses lib event.
Come again?
It uses lib event, like so basically something like an async loop.
Okay. So I have to read about that. Okay.
Yeah. Chalo. Okay. So with respect to the one thing that we all agree upon is like writing it to the disk was costlier, right? So that is where we all what we have to do is we have to write to memory. So the idea is very simple. We write to in memory and we say ki write is done, right? And then we periodically flush the data from the memory, basically doing batch writes and putting it onto the disk. This is great high insert volume because, right, if you see with Bitcast, when we were writing, every write had to do a disk write. And here we are even saving that. We are just doing writes in memory, which is like ultra fast than disk. So we would get even high write throughputs than Bitcast, which is great. But when you are writing this, when the buffer is full, it dumps the data to the disk, but identifying when buffer is full or defining the buffer size, because when it is writing, it would be writing a lot of data onto the disk. You might see a slight pause in the processing. There might be some issues with that. So typically, but still that is not that big of a deal breaker because that's what our proposed solution is, right? So how do we store data to be stored as in buffer that all writes go to the buffer? We can use hash tables, as simple as arrays or queues, anything. It's as simple as it should support the kind of query lookups that we would do. For example, if we store it on list or array, we would still have to support the key lookups. So typically hash table is a good test because that's what the use case is what we are solving for. We are solving for like key value store because similar to Bitcast, this is also key value store. So if I'm batching the writes in memory, I should be able to make query on that because that data is not flushed on disk, because the now reads does not directly go to the disk. It first checks in memory because my data before it being flushed is there only in memory. So I would first have to check memory, and if data is not there, then I'd check for disk. So hash table is a great place, great data structure to store this. Another is tree. Using binary search, so order, log, and lookups and all, we can do that. Red black tree, which is always balanced and stuff, you can use that kind of things to uh, hold all the key values or better part of it in memory and then doing a batch write once the buffer is full. So read, well, now the flow would happen. Write we are sure. So write what happens is write happens on memory, asynchronously write happens on disk. But now reads become a little tricky. Reads don't directly go to the disk because the latest copy of data might be present in memory and not yet flushed to the disk. So reads first go to memory. If the data is there in the memory, it would return that because that has to be the latest copy. If the data or if the key is not there in the memory, it would then make a call to the disk and get the data. It would get the data from the disk. If it is there on the disk, it would return it to the user. If the key is not there on the disk, then it would say key is not present. So reads become slightly inefficient because now it has to do a memory lookup and then go through the disk and get the data. Then it would have to hold some kind of information through which it is able to find it on disk and all.
So basically, tree will be used when we want range-based queries, right? Otherwise, hash table is fine.
Hash table is fine. Yeah, so you can use hash table like implementation or a tree like implementation for that.
Yeah.
Since writes are memory first, if key k is in memory, that will be the latest copy. This is what it is leveraged. So the reads first have to go to memory and then it will go. Yeah. Now comes to the write where periodic flushes. Every t minutes or whenever the buffer is full, we are dumping it to the disk. But how would we dump the data, right? Because it says that we are dumping, but where would we dump it? So if we would dump it into an existing file, right? So we might have like similar to Bitcast, we might have just one file and we're just appending all the data to it. Now this file grows very big. If we just keep on appending the data to the same file, whatever we got, because now there would be repetition of the keys and all. So appending to an existing file is a good solution because you will just have one file in which every time the flush happens, it just appends to that same file. So batch writing to the same file, very similar to Bitcast. But what would happen is flush will take a little extra time because now you're writing a lot of chunks. So your flush will be a costly operation. It would require a pause for the process to handle more requests. It would have to wait until the flush has happened. It will be very similar to GC pause. And the worst part is similar to Bitcast, your file would become too big because you are constantly just appending the data to that one file. So your file would grow out to be very big. Another approach was, instead of adding it to the same file, what if every time we create a fresh file? So every time the flush happens, we create a new file out of it. If we do that, you don't have to append to the existing file. So you just every time you're flushing, you are creating a file name with the timestamp as the file. So you are creating a file with the file name save as timestamp, and you are just appending, or you are just flushing the in-memory hash table onto disk, onto that file, and then done. Right. So this is much faster because you don't have to open the file in append mode. So disk seek to that particular location, although it would be very quick, but still you would not have to do that. Although operating system does store that. So, but a better thing would be that your file is not grown out to be too big. You would have several smaller files, but never one big file. Okay. So, and depending on how you are storing your keys in memory, you can optimize the way you are writing it onto the disk. So let's say it's not mandatory for you to like write it in the CSV format, right? So A comma B, B comma C, C comma D wala format, right? You can just serialize the data structure in your own way because you know that you will always be writing a fresh file. So you can optimize the writes for the reads that would happen in the future. So what do? Is we create a new file for every flush. Let's say my time is increasing in this direction. So 1, 2, 3, 4, 5, 6. So flush 1, flush 2, flush 3, flush 4, flush 5, flush 6. Right. Let's say I'm flushing every minute. So basically, this is the flush that has happened on first minute, second minute, third minute, fourth minute, fifth minute, sixth minute. Flushes are happening in this way. So every time the flush happens, in-memory data structure, in-memory hash table being dumped onto this file. Now, reads become a little tricky. Now, if the data is not there in memory, now what would happen is with Bitcast, it knew that it had an in-memory index to do that lookup. But now what would happen is we don't have an in-memory index because we are already utilizing the memory to hold the in-memory structure for all the batch rates, right? So we don't have extra memory that would keep all the keys similar to Bitcast, right? So what we would have to do is we would have to go through all the files one by one, starting from the most recent flush till the least recent flush, right? So you'd have to start from 6. If you don't find key, then 5. Don't find key, then 4. Let's say in file number 4 you found the key, then you would return that. Right, so you'd have to do this thing because your memory is consumed to hold the writes that are batched. You don't have an in-memory index, so you would be dumping the data. Also, you would be doing a linear scan onto file to find it because you can't do binary search as well, unless you have some meta information which you don't right now. So you cannot do like a order one lookup sort of stuff onto this file. But here, one good thing would be that if an entry, so you would need to go through all the files on the disk and find most recent occurrence of it. So 654321 pe jaoge, and then the recently written entry would be very quicker to find because it would be present in the most recent file which is dumped. Let's say a key was written in the first flush, it was flushed onto the disk, and in let's say after that 1000 flush happened. How would you find out where the key is? You'd have to go through all 1000 flushes from in the descending order, and then you will find the key in the last file that was flushed. And even worse, what if the key does not exist on this? You are going through all the files without, and then eventually find out the key does not exist. That is another problem. Right? So although we are optimizing for some use cases, the gets are becoming very poor. The performance of gets is not good, right? Because we have to go through the files linearly and sequentially to then find out where my key exists or where the latest occurrence of the key is. So now what do we do is, would we go through all the files literally? No, right? Because that's where Dude, that's a naive approach, right? A better approach would be to obviously similar to what we did is this is a perfect case where we would need some sort of indexing, right? Key if the key is present in this file or not. So that's exactly what we'll do. What we'll do is we'll create an index of each file and obviously keep it on the disk because memory there is no place apart from that batch, right? There is no place for you to hold any data. So what would you do is you would create an index for each of the flushed file. So something which would give you answer whose job is to just give you that answer if the key is present or not, right? So because all we care about is the key is present at which offset. If the key is not present, then where, right? So because all we care about is like does the keys is the key present in the file? If it is present, you can either do a linear scan or like go to that position. So this sort of thing is basically flushing out. So we are typically doing what? We are typically flushing out all the key value pairs in sorted order onto the disk. This is a very standard data structure called as SS table, sorted string table. It is a table which is immutable when it is dumped onto the disk. But this is what an SS table actually looks like, this one. So you have the key and the offset. This is very similar to the index structure that we have seen in the previous design questions. So you have the key and you have the offset. But now if you see that we don't have to specify the file because each file has its own set of index. So for each file, you will have an index, which is your SS table. So you would have a key and an offset. A key. So, and this is your data file in which you are storing key value, key value, key value, key value. And what would happen is in the index, you would store key K1 stored at offset 1, key K2 stored at this offset, K3 stored at this offset. Right? It would go there and read the data and then return it. Obviously, some meta information would be there, but this is exactly what sorted string is. And here, K1, K2, K3, K4 are sorted. That's why it is called a sorted string table. And again, if it is sorted, merge sort ka merge algorithm would come into the picture whenever we would have to do some optimization on top of that. And obviously, if it is sorted, it becomes easier for us to do binary search on it and find the key present or not. So in order to find if the key is present in an SS table is what we do is in a file. Okay, if it is present in a file or sorted string table, okay. No, sorted string table also contains the data as well. Oh, sorry, my bad. I don't know what I was thinking. So sorted string table does not is not only this index, but it is also this data file because this is where it is sorted, right? So key value, the entire data structure which is dumped here, it has key value, key value, key value combination plus an index that would hold this information. So now what would happen is you would load this SS table in memory. You would look up the key. If the key is there, so you are basically loading this index in memory. If the key is present, you would go to the offset and read the thing, read the value and return it. If it is not there, you would move to the next file. So now what would happen is we would each of this flushed file would have a small index along with it. Right. So the job of the small index would be you would be loading the small index to see if the file, if the key is present in this file or not. If the key is present in this file, you would go and read it and then basically return it. If it is not there, you would move to the previous file. Check if the key is there. If it is not there, you would move to the next file. If you found the key, you would return it. No, you would return the value. Okay. Yeah, Amrish?
Is this index table itself a mem table? What we talked earlier?
Index is so the index and data file both are stored in memory, but as a separate entity. You would be reading, you can optionally just read the index out of it. You don't have to read the entire data file in memory.
I mean, when we were doing first time writing into that hash table, right? So if we would have maintained this instead of a hash table, if we would have maintained a mem tree, mem table, binary tree.
Yeah, exactly. You can use binary tree or basically mem table in memory.
These would be already sorted.
Yes.
And we just deserialize and automatically it will generate.
Exactly. Even hash table has a very similar implementation. Hash table maybe keys are sorted.
Hash table keys.
So there are multiple ways to implement hash table. The most common ways with modern languages, usme keys are kept sorted.
Oh,
So for
okay.
example, Python dictionaries where keys are kept sorted. So when you iterate through it,
Oh, it's
you
a
would
tree map.
always get keys in
Tree
sorted
map
order.
in Java kind of.
Yeah.
Tree map. Okay.
Yeah.
Okay.
Okay. So, yeah, Rahul.
You mentioned each file will be having a hash table. Like where it's actually stored in the file heading or.
Yeah, this one. So this is that one flushed file, right?
Mhm.
So the flushed file would have two sections. The first one is the index, and second is the actual data where it is contained. So
Inside
when
the
you
file.
read it, you would just read this much of file. Okay. So, yeah, Prabhat, please.
I have a doubt, like it was only append only file, right? So when did we sort it into SS table?
Append only kaha tha? Writes append only file. Which file was append only?
So like these segments that we were storing into the disk.
This one.
Yeah.
यहाँ पे कभी data गया नहीं. What we did was all the writes happened in memory.
Okay.
We never wrote anything to the disk.
Then before flushing, like in memory, we are maintaining it in a sorted order.
In a sorted order, exactly. And then वो पूरा के पूरा is getting dumped onto the disk in sorted order called SS tables.
Okay.
Okay. This way, all the writes just happen in memory. Whatever. Writes are just happening in memory, and once a while it gets flushed onto the disk. And when it is getting flushed, it would be stored in the sorted keys order. Okay. So now, when everything is sorted, and now that we have so many files, you can easily see, like very similar to Bitcast, we can also do merge and compaction, because let's say for a certain key, it was written or it has been updated multiple times. Let's say it was updated in 2, 4, and 6. What you can do is, because now when you are doing the lookups, you are always going from 6, then 5, then 4, then 3, then 2, then 1. Once you have found that key in 6th file, you would never go to 5, 4, 3, 2, 1. Right? So typically the entries which for the same key present in the older files are useless. So that is where, to save the space and to reduce the number of files that you have, and to make gets optimized, because now for get you would have to go through every file one by one. So why would you want to go through a file which has, or go through the entry which has no relevance? So this is where what you would do is you would do merge and compaction. You would, similar to what we did with Bitcast, since the files that are stored onto the disk are immutable and sorted, we'll be merging and compacting them so that we would eventually have just 1 or 2 files that we need, and baki sari files would be deleted. So we merge and compact historical SS tables and create fresh SS indexes, right? Basically fresh SS tables out of it. Merging is order n because data is already sorted, similar to merge logic of merge sort. Okay, but now what about get? Now still there is this one problem. Now with this, what we have actually done is we have minimized the problem. So we have tried to optimize it a bit, like space wise and complexity wise, but there is still the problem, because what if till the time this merge happens, there are KSS tables or K files onto the disk. Now what would happen? But what about get when there are KSS tables? The first read is anyway happening in memory, and then as a fallback is reaching to the disk, because now the read is first going to memory ka read hoga, and then came back. It did not find the key, then it is going back to the disk and then finding it. Now what would happen if there are k such files in the table, like just before the merge and compaction happened, for example, or even after merge and compaction, the number of files grow, and let's say there are 10 files. Now what you'd have to do it is you would have to go through each and every index file. You have to start with the most recent index file, load the index in memory, check for the key if present, then go to the offset, return the value. If the key is not there, go to the previous file and repeat the entire process. Which means your gets, although after merge and compaction, are a little better, but not that optimized. Right? How would we, or how can we make this thing better? Right? What can we use to make this thing better?
Bloom filter.
Answer पहले पता है वरुण. Right. So the idea is very simple. So what do we have here is पहले एक और चीज कवर कर लेते हैं. So we basically what the limitation of bitcast was like we had to keep everything in memory or all the keys in memory. With that, what happened was this was the restriction. But now if you are building something that would make bitcast better, we would be making bitcast better, right? This particular storage. So then we can't have this sort of limitation. All the keys have to be stored in memory. Because like if you see the gets way, we are not having any kind of limitation. Now gets are going through file one by one and then basically finding the key, basically finding the value out of it. So since we have a large number of keys, we cannot have in-memory index. But here we are just trying to address a bitcast limitation. So what if here we try to optimize for the worst case? What's the worst case here? Is even after going through K disk or K files, we found out that key does not exist. This is the worst case. So which means that when we are going through those many files, we are wasting so much of disk IO, eventually finding out that key does not even exist in the system. Right. So this is what the worst case is. So let's optimize. So how would we optimize? So is there an on-disk data structure that can certainly tell me if K is absent? This is a classical case of using a Bloom filter. Right, so similar to how we discussed Bloom filter about in week 2, week 3 time, where what it would do is it is a probabilistic data structure that would, or rather approximate data structure that would give you no if the key is definitely not present, and it would say yes if the key could be present. Right. So in this case, what our worst case is if I somehow find out if my key does not exist at all in the system, then what I can do is if the key doesn't exist at all in the system, I can immediately return a 404. I don't have to go through all the K files and then eventually finding out the key does not exist. But if there is a chance that key exists, then it's okay for me to go through those files one by one, because that's what I'm signing up for, right? Because my keys are much larger than memory, so I can't use that. So this is where Bloom filter comes in. But how come are we able to store a Bloom filter, but not all the keys in memory? Because that's where Bloom filter's virtue comes into the picture, because Bloom filter is very space efficient. Bloom filter does not actually store all the keys ka data as is. It stores hashes of the data and onto a same space. So there are a lot of great resources about Bloom filter. In case you guys don't know about it, definitely go and check it out. Right. So medium users, you can use Bloom filter at plethora of places. A great example would be if you are building medium's recommendation system, you don't want to recommend an article that a user might have already read. Right. So you will use Bloom filter, one created for each user, and you would check if the user has read an article or not, because Bloom filter would deterministically say if a user has not read an article. Basically, if the key is definitely not present on it. And it would say yes if key could be present, which means if Bloom filter says yes, there is a chance that key might not be present. It does not mean that key is definitely not present. Key might not, even it might happen that key could be present, but which also means that even after you go through all of that part, there is a slight possibility where key is not even present there. But that is okay. But you are just trying to minimize the cases where you are definitely sure that key is not existing. You are like saying key does not exist there. Okay. So now what would happen? So with Bloom filter, what would we do is we'll have one Bloom filter structure that would hold information. Lossily, it would hold all the information about all the keys present in the system into this very compact data structure, because that's where Bloom filter makes it very interesting. So it makes this approximation possible by saving a lot of space. It does not require to store actual keys ka data there. So that's what makes it space efficient. So we can have a tiny Bloom filter stored in memory, or basically kept in memory, that has this kind of information. So yeah, that's what about Bloom filter is. Then how would we, are there any questions still now? Was everyone aware of Bloom filter? How many of you were not aware of Bloom filter? stars. Okay. Nice. So folks who are not aware of Bloom filter, please go ahead and read about it. It's a very interesting data structure. There are a couple of data structures better than Bloom filter, but to start with, Bloom filter is a great start. A lot of companies use it. I've used it very extensively, and it actually makes a lot of sense to, whenever you have a chance to like ensure that key is definitely not present, so then I don't want to even waste any of my IO. That's where Bloom filter shines a lot. So medium articles, we'll also discuss Tinder design. That's where Bloom filter also comes handy. Like for example, now that we are on that topic, how about implementing the swipe matches on Tinder such that a person that you have already swiped before, either right or left, you should not be getting the same recommendation again. If you were to implement that, that's also a great place to leverage Bloom filter. कि एक बार swipe हो गया, you are not seeing them again because you have made a decision either yes or no on that, right? So Tinder's second biggest problem is that, so you can very easily implement it using Bloom filter. So you would have one Bloom filter every user for the Tinder wala use case and for medium wala use case. It does not take a lot of space to implement it, a very tiny one.
So what's better than Bloom filter actually?
There are two papers published about it, not strangely not used in production by a lot of companies. There are only a couple who are using them. You can search for better Bloom filter, you will find two papers.
Okay.
Right. Unfortunately, there is no name. I just know the person and the college from which he was from, because that was my rival college. I was like, "Arey baap re, wahan pe invention hua." So that's how I actually recall that there are two papers about it.
So just to ask
yeah,
one question, so Bloom filter, like, is this some data store
it's
or
a data structure.
so is it provided by the language?
There are libraries. It is not given by language. There are libraries that implement it.
Okay.
I think it's very simple to explain. Maybe I can try in a minute.
Please go ahead.
So basically, when you create a map, right, key value pair. So let's say you create K1, you have a hashed it. So there are three values which are falling to the same key K. So you added the count. But if you want to check if there's a key present corresponding after hashing, that key is present, it means there exists a value, right? So that's the way it goes. Like if you have
like this very simple way, if it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
You have fixed size, yeah.
So I've taken a hash space of 16. Let's say I have let's take an example of keys and values, normal keys and values. Let's say I have key, let's say I have apple, I have ball, I have cat. Okay, let's say I passed it through a hash function, and my hash function pe apple ke against came out to be 19. Okay, for ball it came out to be 12. For cat it came out to be 13. So what I would do is, in this hash space, in this very, very small hash space, I would mark, oh, sorry, not 19. 19 this is, let's say, 11. 11 ke jagah 6 lene pe. Okay. 6, 12 and 13. So I would mark 6 as taken. Basically, bit set to 1. These are all bits. Yeah. So this would be set to 1. Okay, this is taken. Then 12 is taken and 13 is taken. Okay. Let's say I've added dog. Let's have added dog to the list. Now, since this is hash space, this is smaller, there is a chance of collision, right? Now, since there is a chance of collision, what would happen is, let's say dog also came out to be at position 6. So now what I would do is I would mark this as 1 because this is just bits. It can be 0 or 1, right? So now for dog, it came out to be 6. So 6 pe aa gaya. So my hash space looks like for 6, 1, 12, 1 and 13, 1. It's not counter. It's just zeros and ones. Now what would happen is, let's say I'm looking for a key called dog. Let's say I'm looking for dog. Does dog exist? So what I would do it is, I would do a hash of dog. And what I would get 6. I would check if 6 is 1. If 6 ka bit is equal to 1, is it? Yes. So basically dog could be, because now it is one. Dog could be present. It is not guaranteed that dog is present. It is could be present. Why? Because let's say there is another word that came in called zebra. And when I apply hash function on zebra, I also get a 6. Zebra is not yet added, right? But I'm looking out for a word like zebra, right? So if I'm looking out for a word like zebra, let me write it here. So does zebra exist? I've applied a hash function on zebra and I got 6. Now, once I got 6, I would check if bit at position 6 is equal to 1. Is it? Yes, it is. Right? Because bit at position 6 is equal to 1. Now, what does this mean? That zebra could be present, but is zebra present? Because right now I just have 4 keys: apple, ball, cat, and dog. Zebra is not there, right? But still, so this is if I'm getting a true out of my bit cast. So if the corresponding bit is set, it means that key could be present because there are chances of collisions, right? But what if there is a word called home? Now, when I apply hash of home, I got 3. I do check bit of 3. Bit of 3 is 0. Bit of 3 is 0. It means that I have never seen the word home in my dictionary. And because if it would have been there, I would have seen a 1 at that spot. Right? Since it is not there, since it is 0, since it is equal to 0, then answer is definite no. This is yes, maybe. Right. This is exactly how Bloom filters work.
Okay, and yeah, I can now think how exactly it can be used for a recommendation system. Basically, whether user has read something, तो वो set हो जाएगा, and
correct.
Like just to give an idea कि ये user ने मतलब इससे related कुछ पढ़ा है, तो is it मतलब अब वो algorithm का basically काम होगा ना, how exactly
उसके ऊपर क्या करना है वो कर सकता है. Now this is again, this could be very well applied at Tinder use case. Let's say for a user, I've seen a girl, I have done a left or right swipe, irrespective of that corresponding bit would be set to 1. Right. But jiske against bit is definitely 0 means I have definitely not seen this girl.
तो that would totally depend कि हमारा hash function कैसा है,
hash function कैसा है, how big is your hash space, because depending on that you would need to allocate that much of basically blob store for you, or basically a blob for you, a blob for you, क्योंकि उतने bytes, let's say 1 KB blob, which means you have 1024 slots to fill, or rather उससे भी ज़्यादा होगा, 1024 into 8, right? So 8096 slots for you to fill in. So that big is your space or your bit array. This way you would be setting the bits. And basically this is exactly how Bloom filters are meant to be used. And if you see, like, you can add thousands of words here. Like you just see higher collisions. So there is this, so basically Bloom filter paper gives out this formula ki how big should your bit array be, depending on how many unique keys do you have in your system. Right? उसके ऊपर से there is this formula through which you can very easily find out कि कितना बड़ा Bloom filter चाहिए, और rather कितना बड़ा bit array चाहिए.
So this जब भी computation होगा, this will be every time loaded onto the memory, or is it something where exactly will it be stored, like on
this will be stored on disk and loaded in memory to find out if it exists or not. But instead of loading all the keys, you are just loading this tiny bit. If you see, this is just 16 bits, right? Just 2 bytes of space to hold like so many keys ka information. Correct?
Yeah.
That's why it is basically, that is exactly why these are very space efficient.
Okay, so for example, for the post recommendation Instagram, and if you have like a 2 bits Bloom filter, and if tomorrow like post increases, like how do you expand it?
So Bloom filter, you will add more space and then you will rehash all the keys, because there is no way to do it. You have to rehash everything. So that's where you would always have it like a very big thing. Not too big, not too small, but a little over provision. but you should be prepared about it that if you'd want to do that, you would always be ready for rehashing the things that you have already seen. So there has to be some place, right? Because it can't be, so it's not that Bloom filter is the source of truth, right? You would always have one actual database where you are actually storing all the keys and all. You'd have that. It's not that you are not even storing the keys anywhere, because you'd have to somewhere store keys and the values. You would iterate on that and rebuild Bloom filter out of it. Right? Got it?
Yeah.
Sure. Oh, we also covered Bloom filter. Nice. Now, now coming back to this, how do we handle data loss? So we optimize it. Now we optimize for the worst case of the system that we're building, the LSN tree, like the worst case of it. Key, even after going through all of these files, if the key is not there. So if the key is definitely not there, we are just making one lookup on Bloom filter, and we would automatically, if it is 0, we'd say key existing. Right? And by the way, in actual Bloom filter, not just one hash function, there are multiple hash functions that are used. In parallel, 3 or 4 hash functions are recommended. Right? So thoda paper pad lena, you'll find a lot of stuff around it. But yeah, this is what the foundation looks like for that. So what would happen for data loss? Because what would happen is when you are writing the data in memory, because up till now the writes have been where? Writes have been in memory. Wherever the F is written, this is where the flush is happening. Let's say we are flushing the data every 3 times. So let's say once the flush happened and just before the next flush, there is a crash happening. So the data which was written during this time is lost. Right. So that is where you'd have to have an on disk append only commit log, which would store all the writes, so that even if your process crashes, it can rebuild the in-memory structure using some data, right? So that's where it would use the commit log to rebuild whatever it had in the index, right? So that's why commit log is very important. So you can't have zero data loss if you are solely relying on RAM. Although there are specialized RAM, but those are very expensive, which are non-volatile RAMs, NVMEs, non-volatile memory. They are very costly. So people don't typically recommend that. So, but here in general, it's about like if you're storing data in memory, you should be ready for data loss. But if you don't want to have data loss, you would have to persist it somewhere and have a process of like reloading it. Whenever you are booting up, you would reload this commit file and then rebuild the in-memory data structure. So commit log would look something like this. You would have put K1 V1, put K2 V2, put K3 V3, and then delete K2. These are the actual operations which are being fired, but all the write, not the get operations, because we don't care about that. So all the update, all the write operations go here, and every time your thing boots, it would reload this commit log. Right, but once the flush has happened, once the flush is successful, this commit log is also truncated to 0, because now since it is already flushed onto a persistent new file, why would you need to keep this another file in memory or on disk? Right, you don't need that. You would be flushing it. So every time the flush happens, you would also truncate the commit log. Right. Now,
So whenever we allocate this mem table in memory, at same time new commit log gets created.
Yes.
Okay.
So we basically truncate the commit log instead of creating a new file.
Okay. Yeah. Okay. Okay.
So every time the flush happens, the in-memory table is flushed onto the disk, and the commit log is truncated.
Okay.
So if we have a commit log, how it is faster than Bitcast? It is not. We started with this assumption that let's make it faster, but if we need to have zero data loss, we have to write somewhere. We cannot avoid this. We have to write somewhere the put and the delete operations that we have made. So all the write operations has to go somewhere. But then how is it better than Bitcast? So it does not have an in-memory index to make this faster. It doesn't play by that constraint that all of your keys, or rather you should be able to hold all of your keys in memory. It does not hold by that constraint, because you can have as many keys as you want now, right? You are bounded by disk storage and not memory, right? So this is a massive advantage over Bitcast. Yeah, this is what, and obviously there are multiple tierings of LSM tree, because that's why the name comes in trees, LSM trees. So there are multiple tierings, but yeah, this is the core foundation of it. And this sort of data structures is again not obscure, very heavily used in production. A lot of databases use it. A lot of embedded databases, you can go through LevelDB, RocksDB to find more fascinating world of embedded databases. So LevelDB is something that I would heavily recommend. Go through the internals of it. There are so many nice variations that they have applied, so many nice optimizations that they have applied. I've learned a lot while I was going through it. So LevelDB is something that you should definitely check out. So any question before we take on a break and then cover with you? Right. Sure. Awesome. So it's only 5. We'll take a break for 5 minutes. We'll catch up at 5 and then cover YouTube. High throughput, basically any pipeline which is computation heavy. Up till now we were like storage heavy, high throughput. Now it is basically computation heavy workloads कैसे optimize करेंगे. We'll take a look at. So basically drilling down the core problem of YouTube. Okay. Awesome. See you guys at 5. let's jump into YouTube. Okay. The According to you, what is the biggest challenge of YouTube?
Storage.
Encoding the videos in different formats.
Exactly. So, by the way, why not storage? Because storage is cheap. Yeah, basically storage is just uploading a file and then serving it, right? But once you upload the file, that's when you would have to process the file. It's not that, like, I'll give you a small example. When I was uploading, so all the live classes that we have, I record all the sessions on Zoom. Once I have the file, I used to upload it on Google Drive. Right? When I upload the file in Google Drive and you watch it, you watch the recording. When you are opening that file, the file is sent to you byte by byte, right? So as it is, whatever is uploaded, it is basically sent to you. Now through this, what happened is like storage, like TK 500 MB of video, it is stored on the storage and you're getting it back. But now what would happen is on when you do that, what if the person who is consuming the video is on a 2G internet? And your video is very high resolution HD video, right? That user will have a very poor performance, right? Rather not performance, but very poor experience, because most of the time it would be just loading because the amount of bytes transferred would not be big enough to render a few frames of the video. Problem number one. Problem number two is with respect to the video formats. Let's say I upload a file in a very stupid format called .mov. Not a lot of devices support it. Now, what would happen is if your video is being streamed to a different device, to a device that does not support that encoding, then the user will not able to play the file only. So when you see that error, na ki media playback, some error happened, or your browser is unable to play the file, this is exactly what is that. The video is yet to be transcoded in not just YouTube, but a lot of other sites. If you upload a video onto a very random format and open it on a device, so वहाँ पे the video player would give you that error that not I'm unable to play this video file, right? So although it's like basically concurrent viewing could be a challenge, but like obviously I would not tell you all folks, like it's the magic of the CDNs that do it. Although handling transactions is a good big of a challenge, but with respect to pure of a content delivery, when so many people upload so many videos or so many videos like of such big lengths and all, like HD videos 2 to 3 GB big, processing them is a massive challenge. It's a very CPU intensive job and you require clusters and plethora of machines to process that stuff, right? So scaling YouTube is as simple, like for readers, right? For viewers, it's very simple. You just like video is stored on a cloud blob storage like S3, and it is served via CDN like Akamai Cloudflare or basically Google's on CDN. So that's not big of a challenge, because once the data is moved to that CDN, the user would automatically get a good experience and immediately video would be streamed, right? And obviously the main origin would also not have too much of load to serve the video data, right? So basically that's where caching comes into basically caching comes in very handy. So you do, and what you'd have is in a setup like YouTube, you would always have like two paths, one for video streaming, another one for core API, which would drive your authentication, your feed, your recommendation, your search and other stuff, right? So those core sets of APIs and REST-based services and microservices and whatnot, they're different. And video streaming is a totally different ballgame. And this is typically not served through your API servers. API servers would generate the link, or they would generate the URL from which you would get the data, but it would not be doing the heavy load of serving it. It would be done through a cloud blob storage. And there it would require scaling and other challenges. Right. So these are typically two workflows there. Yeah, Amrish?
I have a very basic question related to CDN. So for case of like YouTube, it's fine. We put the video and somebody is doing streaming because all the videos are free kind of, right? So, but if there's a, let's say Netflix or Dropbox where authentication is required, CDN doesn't do any authentication. So
Digital signatures. This is where digital signatures come in, not digital signature, but rather signed URLs come in. So your request would still have to go through API server.
Okay.
The API server would generate, so it would check if the user is authenticated and can access this video. For example, Hotstar's VIP versus premium. Right. So if you are, even if you have a VIP, you are not allowed to access premium content on it. Right. So what happens is when the request would first go to API server. API server would check if the user is allowed to view this content or not. If it is allowed to view this content, it would generate a signed URL. And this signed URL would be would have it sync with CDN. So CDNs may not everything is made public. CDN pay you can still have private, and it would require the signed URL to access it. Folks from Akamai, can you please pitch in? Varun?
What exactly?
So how does platforms like how does Akamai protect the premium content?
Not exactly. Just I can tell about Hotstar. So they came up with something called as access revocation. So if they find that अब वो stream का link अगर मिल गया किसी को, someone finds the stream link and start sharing it again. So there was something called that as access revocation कि हर link पे there was something appended whether how many times or like कितने देर तक ये link active रहेगा. There was some technology they built along with Hotstar. मतलब testing उनके लिए ही किया था ये. I'm not, but this was implemented last time to prevent illegal streams.
So it's just number of users viewing, right? It's not only this user is allowed to view.
No, CDN does not have authentication, but basically somehow the authenticity of the request needs to be checked, and for that signatures or signed URLs come in very handy. So every once a while a request would go to an API server which would see if the user has access to this content and what kind of thing. So then it would then generate a signed URL. This signed URL is nothing but your stream key that would be also updated with CDN. So that CDN, once it gets that key, it would get the data. So let's say every 5 minutes, the request might go to API server. API server would then create a signed URL, give it to the client. The client would use that URL to then get the stream for next 5 minutes. Then it would again expire. It would make another call to API server, get the signed URL, go to CDN, get the data, and so on and so forth. So this is one way that I have seen.
So signed URL is specific to user.
Signed URL is specific to user.
So
and more specifically to a request.
So how does this CDN will decrypt that signed URL?
No, CDN would just check if the signature is valid, because it would have the secret key.
CDN will have the secret key.
Yes. So this is how we have protected our content.
So that secret key is for any video, whatever request comes, it's one global key protected in CDN for that account maybe.
Yes.
Okay.
Yeah, Varun, you want to say something?
I think the CDN doesn't need to know the secret for validating a signature. You can validate a signature with a public key itself, which is So I mean, and it's a public key, so you don't. The CDN provider doesn't need a secret per se.
Oh, correct. My bad.
Problem in that case is if somebody knows the signed URL, anybody sends that signed URL, because the secret key is with them, it will be always valid.
No, but signed URL is for a very short duration. Let's say 5 minutes.
Okay, only 5 minutes. Okay.
Only 5 minutes.
Then it will refresh it.
Yeah. So then every 5 minutes, your client would have to make call to API server to get the new signed URL.
New signed URL means what?
For next 5 minutes. Yeah.
So it's a URL, right? Maybe it adds timestamp in that URL, maybe, right?
Yeah. So every signature will have an expiration. Huh?
Oh, okay. So from that,
it will expire after that time.
Okay, got it. Okay.
And yeah, I don't know why I said I'm out of my mind today. Oh yeah. Basically, just to verify signature, you don't really need secret key. Only for encoding or basically only for creating the signature you need it. This is very similar to JWT token.
Yeah, got it.
JW token ka anyone can verify if it is correct or not, because that's what you have to check if it is expired or not, and if no one has actually tried to alter the data.
Yeah. So
Right.
basically, that signed URL will have the expiry time, and
Yes.
which they can decrypt using only the secret
It
key.
doesn't really need to. It just have to verify the signature that no one has altered the expiration time. As simple as that.
Okay.
Barabar?
This
Because
is
agar
very similar.
Hmm.
This is very similar like the single sign-on when you use Google to sign into some other service, right? That kind of third-party authentication. We use JWT tokens. The same workflow. Like if you use Gmail to sign into some other service, right? So the Gmail shares that authentication, does it, and then provides some third-party information to the CDN, and they can take over from there.
Yeah, that also uses the same mechanism, right? Some hashing thing, and if they have the key registered,
yes,
you get it. And
yes. Yeah. So basically, CDN like any other thing is just like very dumb. It just knows how to serve it. It would just check once the request comes in, if it is valid or not. If it is valid, it would just serve the data.
Worst thing, maybe 5 minutes somebody can overlap.
Yeah, exactly. बस उतना ही जाएगा, उससे ज़्यादा नहीं जाएगा.
But Hotstar still has not fixed it. Like even if you get the stream link for any premium content, you can like stream it till now. As in, उन्होंने नहीं लगा पाया. They have not solved it yet completely. And this is like being exploited 5 years से. You just need the cookie.
आप जाके बताया.
हाँ ना यार, क्या
Day 1 पे बताना चाहिए था.
I should move this to day 1. पता चल जाता सबको. अरे यार.
So ऐसा, I'm not sure. नहीं, as in this you will find many streams online for Hotstar. जब कुछ भी प्रीमियम या जैसे लाइव चल रहा था, like IPL जब चल रहा था, तो
मैं थोड़ी देर के लिए रिकॉर्डिंग स्टॉप कर दूंगा, वो दे देना लिंक. नहीं, this is like what हाँ. See, what I've learned is whenever something is out on the internet, it's never 100% foolproof. You just try to make it harder for people to crack it. It's just that. Like a very simple example is how I'm hosting videos on Relog. I've used Vimeo. Vimeo is not foolproof. Like even DMark is not foolproof.
Okay, just एक चीज और मैं बताता हूँ यहाँ पे. Like when you are uploading on Google Drive, so you disable the download button, right? हाँ, तो but still I can go in network tab and download the video.
क्या कर रहे हो?
Just as an example.
Vimeo के भी downloaders आते हैं, वो भी कर सकते हैं.
I know, मुझे पता चला अभी, but I just want to make it a little harder so that people who don't know at least वहाँ से बच जाए. But obviously, when I was speaking to customer support of Vimeo and just got their engineer on call to understand how can I protect my video, he said, bro, there is no way to do it. Once the packet is streamed, it's streamed. So you would have no control over it. Anyone can just copy. Like the worst part is someone can just play your video, do a screen recording and share. It would look exactly like a video. I said, yeah, that's true.
One feature I worked on is watermarking. So where we would encode distinct marks inside the video for individual users. So once a leak happened, you could trace that to which user, yeah, and then kind of blacklist that user. So you people less likely to share.
So I know there are, but implementing that solution was a much tougher for me. So I said,
yeah, actually it depends, like putting that much security and what's the advantage you are getting.
This is mainly for like Game of Thrones kind of very high.
Game of Thrones kind of thing. Every single thing has to be like really severely protected, right? So वहाँ पे तो सब करना ही पड़ता है.
So actually, I was working in a cryptography team 4-5 years back. So they it's like our founder was this Paul Kocher, who has broken AES key and all. He is very renowned guy. So our product was like you can decrypt the keys or break the keys of a mobile phone, capturing the electromagnetic waves of your mobile if you have an analyzer, right? But that to break that, you need the analyzer $30-40K, and that should be in proximity of your mobile. So who is going to, and is it that like mobile companies are so much eager to invest that much money to
say
so that the design
protect against that.
yeah, that. So that was very good concept, and our company has acquired that, but they could never make money because it couldn't sell. People never want to provide that for security. So that's the thing. So you can Google differential power DPA, differential power analysis for the security checks. So that's a very fundu technology, but nobody uses.
By the way, Arpit, as in Unacademy also uses Akamai, right? I saw that and they signed a deal for hosting.
You saw that? Is that open for all the internal employees?
No, yeah, as in they send out newsletters of the biggest wins. So of across. जब था उस समय आया था, मतलब this was last year का मैं बता रहा हूँ कि.
Exactly, last year ही किया था. We did sign a deal.
पहले था, फिर किसी और को चल गया था, वहां पे वैसे लिखा भी था ब्लॉग में कि Unacademy is very, मतलब पैसों के मामले में, मतलब they had a very pressuring offer from other vendor and उसके कारण और ज्यादा इनको स्ट्रेच करना पड़ रहा है, ऐसा कुछ था.
ये पता तो जाओ यार. So we did sign a deal with Akamai, but we did not use it for first 4 months because Akamai support is pathetic. Matlab, we were facing issues with network packets being dropped from the Akamai side. When we raised a concern, Akamai people did not help us at all. We were struggling with support for like 4 months, and then finally it got resolved. And then we started using Akamai. Till then, we were paying for two, AWS Shield and Akamai. Both we were paying for. So Akamai not as a CDN, but as a WAF. So WAF case mein we were seeing this problem. CDN was working fine. So CDN ke liye we use CloudFront and Akamai both.
Yeah, okay. I think वो Shites Akamai में it's called Shites Shield, something of that sort.
हाँ वैसे. Oh, fun times. So yeah, we discussed quite a bit of things. Fun. So with video upload, what you do is similar to what we discussed with the first week. Video upload, there are multiple ways to implement it. So user, when uploading video, can directly upload raw video onto blob storage, like by getting signed URL from S3 and directly upload it to S3 without going through the API servers and all. You can do that. And then you would have meta information to be kept in one of the database. So your blob storage would be the one that would hold all of your video, actual raw files of video. API server would serve normal APIs. You would have a database, rather multiple databases to hold multiple types of information that you have in a system. So let's take an example, blob storage, S3, Azure blob storage, pick any, let's pick S3. And video metadata database, SQL, NoSQL, what's your take? Which database would you pick?
NoSQL is good because, I mean, we don't need ACID properties.
Perfect. We don't need ACID properties. You don't need cross table joins sort of stuff because it's like pretty centric to a certain channel, right? So for example, एक channel के सारे videos would be like going through one together, right? So you don't need foreign keys and all stuff here. You just need like maybe IDs and all, but not like very strict constraints, right? So you would definitely not do that. So you can very well pick NoSQL for this solution. So metadata database or one entry of a video would look like this: some video ID, user's information, and some URL, which is like path to your raw video. This is a typical structure, but do you think that this structure is okay for YouTube? So video ID, user, and URL.
Views and stuff.
What custom?
The number of views and
both analytics hai, but is there anything missing here? मतलब कोई चीज गलत है क्या?
I mean, why will you store the user info with every video? I mean, it's a too much. If a user updates his name or something, it's a little difficult.
That is one concern. Okay, but
also, why would you store the path of raw video?
Why not? Because that's how you'd find the video na, to stream.
But we are going to be dividing that, like we are going to be transporting that into different types.
हाँ ठीक है, वो आगे address करेंगे ना अभी, आगे address करेंगे. But one thing is, like, we typically think about user, although I'm sure that you all would have this thing in mind, but this user is just channel. Right? So user should not be the key, but channel should be. right? So that one layer of abstraction, because a user does not upload a video is belonging to a channel. Why I'm stressing this point is because I was rejected from interview because of this. I was asked to design YouTube, and I said, for every video, I would have video ID, user, and other information. And then we were discussing. And at the end, I had a pretty neat solution. And he said, but why did you choose user? Isn't a channel part of it? Because video belongs to a channel. And then he stretched me like anything on it. How can you design like this? And the company was a gaming company. He was very particular about the kind of terms I used, although it was very evident that I was going about channel, but I was constantly saying user. So just basically using the right term there or the right thing would have made the difference. So instead of, with respect to YouTube, there is always a concept of channel, and videos are uploaded onto a channel. So storing channel ID would do the job. What Varun suggested was like to not store the information of all the channel with every video that it has. So that's a take that we can have. Like either go with the SQL side of things where you are having ID and then you dereference it whenever you are accessing it. So you would make two get calls, one for the video and one for the channel details, right? Another way is to keep the data along with the video. But here the problem comes in, what if a channel changes its name? You would have to go through all the videos and update the channel name.
Yeah.
Right. This
That's
is
a denormalization problem, right?
That's denormalization problem. Right. So depending on the volume of data. So what I feel is for YouTube, it's still okay to do this because there would be 1,000 at max 2,000 or 10,000 videos. That's still nothing as compared to if it was Twitter, I would have said no, because Twitter you can have like 100,000 tweets, like where the volume is very bulky. You cannot afford that, right? But when, let's say, on an average, a channel only has 50 videos on YouTube, 50 or 56 videos on YouTube, which is nothing. So even if you'd have to go through all the videos and update this meta information, you can take that call because you are saving one get on every request. So depending on the kind of use case, you can pick one over other. I'm not giving a judgment out here, but it would be a personal choice whether to denormalize it and store it, or whether to use a referential key and then make another get.
No, can't use caching to just have video information.
You can do that. You can
channel information and not do the get.
Do that. Yeah, you can do that. Get on a database or a get on a cache. It's perfectly fine. But at the end, you'd have to make another network call. It's just about saving that another network call.
I mean, DB network call and then accessing DB would be more costlier than cache anyway. But yeah, so rather than putting all data together, just on demand, you
on demand kar sakte. See, again, depending on the, but my take would be if the updation volume is very less, or rather how frequently is a user to update its name or the denormalized information. If it's not that frequent, denormalize and store.
Yeah, generally people won't change channel name because once it's popular,
that's identity. That becomes the part of identity. Yeah. Right. So there are multiple scenarios. So depending on the kind of product you are working on, you'd have to take that call. There is no one right answer for this. Okay. So the URL would be updated and set when the upload is finished. Then the URL would be updated. Now here is the main. Here's an interesting part which we covered, but just reiterating it. So convention over configuration. So the profile picture of the channel, right? What we discussed with image upload service, we would have another image upload service which then updates it and all. You can also go by a convention based approach, where what you would have is you would have it by convention, where you can use user id.jpg as part here, like similar to what we discussed with the Gravitas design. Na? Similar to that, you can pick one over other depending on the kind of system you are playing with. So you'd always need to understand when you can pick convention and when you will pick configuration. Okay. So here I would go for convention because in the user's feed, and there would be plethora of places where once the photo is uploaded, people would really want to see in real time every place the photo or the profile pic getting updated. So this is something that I would go for convention over configuration.
Sorry, I didn't get this convention version.
एक बार वो ग्रेविटर वाला देख लेना फोर्थ वीक पे आपका बचा होगा देखा.
Okay, thanks.
ठीक है. Now upload video upload request flow is like user clicks on upload video. यहाँ पे one thing that we definitely want to think about is like making user experience better. So when user clicks on upload video, this results in API call going to the API server. It returns boilerplate video details, but what we definitely need is just ID and like signed URL on which video needs to be uploaded. So the response that we get, I want to upload a video, I would get a signed URL out of it. This signed URL is where my client would be uploading the video to. So it will be the blob storage on which the video is directly getting uploaded. Once the user initiates the upload by using drag and drop, this has to run in background. And in foreground, you would let user update the video details. For example, video title, video description, video tags, language, subtitles, and all of those stuff, right? So you'd always need to understand that better user experience would always win. So always design the system with respect to best user experience, right? Not just engineering wise, but also like user experience is very, very, very important, right? So your tech should never come in the way of a better UX, because your better UX would make your business sustain for a long time. But just because if it's an engineering challenge, you won't do it. That's not the kind of excuse that any company would want to hear. So your tech should be flexible enough to accommodate the prime user experience. Okay. So while the video is uploading, the user should be able to fill out forms, meta information about the video, and then just basically keep the document updated. Once the video upload is done, your client would make another call and just upload, would say that, okay, this video is uploaded to this video ID, and this is the URL from the blob storage and all, like that information. So this is something that needs to be taken care of. This is a very big flow, just basically compressed into a smaller like workflow here. But you'd have to think at every step on how would you make a user experience better, because that is very critical. Okay. Then how would we know that upload is done? JS events. Once the file upload is done, you would get a JavaScript event through which you will make another API call and say, okay, upload is done. So something similar to this. So this is how your backend server would know that upload is done, and then it can trigger off something like transcoding and all. So once the client understands that the upload is completed, it would make an API call to, like, let's say we have another key called raw upload, which is set to false key, which is waiting for the video to be uploaded. And then it would be set to true once the video upload is done. Like you might have a key so that you can render the interface accordingly.
So is it server sent event thing?
Not server sent event, but it would make a normal HTTP call, a normal REST call, not an SCC.
Okay.
Right? A normal JavaScript handler would do the job, because once the file upload is done, there is an event which is triggered. You can capture that event and do any action.
So we generally use in our product server sent event, like say any async calls. Once it's done, for that client to get to know, we send.
Yeah. If you have an open socket connection, you can use that server side event. Also, you can use anything fancy, or normal HTTP request also works. Now, what if your upload failed? So you might want to run a cleanup job when upload failed, depending on the kind of workflow that you are having. Like for example, if you are creating BB entry even before publishing, that you'd have to do anyways. So you'd have to delete all of those things, or basically mark it as draft and all. Like just go through YouTube's interface and just try to upload a dummy video onto a channel and mark it as private, and see the kind of steps it there, and then design it. Like there are so many intricate details that you'll find when you are picking up an implementation like this. So typically whenever you hit the button to upload a video, and then you start uploading a video, even then at that time one entry in the database is created with status being draft. Once a video is in draft, you can always update the video title description, and it might happen that video upload is failing, right? And if it failed, you can re-upload the video, but then the entry would still be there, which would make your video in the draft state, right? So this is an optional step where you might, if your video upload fail, you might want to do a cleanup or not. because in case of YouTube, it does not do a cleanup. It just creates that entry and keeps it in the draft state. But you can choose if you want to do a cleanup or not, right? So what do we have? So
you are doing to upload through browser or some client?
Browser.
So how will you see the DB thing that is drafted?
What in DB? What is the?
You said it's in draft mode.
So draft mode pay. See, in the database, whenever the entry is created for the videos, this entry.
Okay.
Right. Here there would be a field called status.
Okay.
This status would be draft by default.
Okay.
Right. If the video upload failed, it would have no impact whatsoever. It would still stay in draft. But if the video upload is success, this status, or basically once you hit the publish and all, this status would be changed to published. Right. So this is how basically this is where the play would happen, right? Depending on the status, and this would be changed depending on if my video upload passed or not, on what happened where and why, like this. So you might want to go through. So if the upload failed, let's say client closed the browser and there is no web worker running behind to do that part in the background. If your client failed and something happened, so video would have your interface should see that video upload failed, and it would remain in the draft state. And then you might have a cleanup job to clean those videos up. So now what would happen is here one more thing is that apart from this thing, you should also have a timeout. Like let's say when you're uploading a video, you should also have a timeout key. If the video does not upload after like 2 hours or 3 hours or something, you would assume that it is done or it failed, right? You would have to also consider that use case where you might want to run a cleanup job. Like if you are ever doing a cleanup, you might want to run a cleanup job once that particular timeout also happened. So raw upload falls and timeout happened, then you would delete it. So you can consider all of those other options. It's just about being aware of certain of all the possible error situations here. So a high level stuff could, like up till now, it would look something like this. So user would be there, user communicating with API server, API server giving out the signed URL, user using the signed URL, uploading it to the blob storage, then API server, then you might have a cron which would see that, okay, this video was created, not published, was created at this time. It is already 3 hours, but still raw upload is not set to true. So I think it should remain in the draft set, or it is eligible for the cleanup, and it would do a cleanup if required, if you are having that cleanup file of flow. So then it would go through the database and delete unuploaded videos and delete the data from the blob storage as well. When the multi-part upload fails, or S3 also stores it for some reason, it does not auto delete it. So you would have to delete those failed uploads from S3 as well. So when the chunks were uploaded in the failed state. So there are multiple workflows that you need to think about it. So we can dive into details of each and every one of it, but it depends on the kind of implementation that we're picking. Obviously, there is no one right way to build it. Depending on the product flow, we can pick and choose between one versus other. Okay. Now comes the most interesting part of videos of YouTube, where we need transcoding. So transcoding is an extremely important step for any video hosting website like Vimeo, YouTube, or even Hotstar, Netflix. Everyone needs transcoding. So raw videos are typically uploaded in any format that user like AVI, MOV, MP4, any format. Client device might not support it. Number one, client device might have a very poor internet connection. So video having higher bitrate, like let's say you have recorded video in super HD format, like basically about 1080p resolution. But if you did, it would have a high bitrate, high quality. Now what would happen is when it would be streamed to the user, it would drain higher. It would drain the battery faster. It would drain the user's device's battery faster, and it would require faster internet speed to render or to play that video. So this is major problem. So that's why when video is uploaded on YouTube, it does a bunch of transcoding into various formats. Basically, most common format that almost all the devices would support, and then it would do. It would then create that video into multiple resolutions. So starting from 240p to 720p, or basically whatever the resolution, the max resolution that video is uploaded in. Till all of those resolutions, it would create and keep the video files ready. Then depending on the user's network and battery and other rate, it would pick which resolution it should stream the video in, and then it would do auto adjustment of the bit rates and all, right, of the resolutions and the bit rates. Right, so this is an important step to give a better user experience. So that basically a user ka video, it should never stop playing. If the internet is flaky, it should downgrade it to a lower resolution. And when it downgrades to the lower resolution, it would require that data to be present so that it can stream it. There are two ways to do it. Either transcode and keep the format and keep the video ready in all possible resolutions. Number two, do an on-demand transcoding and then send. Right, so there are two ways to do it. In this one, we'll be tackling about, let's say every video is getting transcoded, right? That's where you would have a very high throughput requirement. If the videos uploaded, you have to do the transcoding very fast for almost all the videos which are uploaded. But there is also another way where you are doing on-demand transcoding. So let's say you uploaded video in 720p. User has a very slow internet. User can only stream like 240p videos. The request went for 240p. Your this thing found out that 240p ka video is not yet transcoded. It's not ready, right? So now what it would do is this thing would do an on-demand transcoding and on-demand conversion of video from one resolution to another and then stream it back. So again, not an optimal solution, but it should be there because you cannot transcode all possible videos out there. So there has to be an on-demand transcoding in place. Right, so it would do on-demand transcoding of any request that comes in. If it does not, it would basically trigger on-demand transcoding of it. Okay, of bitrate. Yeah, Amrish.
Basically, on-demand transcoding, would it be time-consuming?
It is time-consuming.
So how will they then I mean stream on-demand kind of?
No, but it would not be that time-consuming, na?
Okay. So
मतलब इतना नहीं होगा, but it would see your video to continuously play, right? It would definitely require, let's say, 1 minute worth of video being sent to the, or basically 1 minute worth of chunk to be sent to the client. And that 1 minute ka chunk could be as big as like 2 MB per se. At 240 resolution, it could be around 2 to 5 MB. Right? If you have that much of thing, and the actual video ka length pe that 1 MB ka chunk would be 50 MB. Right? The 50 MB ka blob storage se read karke on demand transferred and send of like 5 MB. It won't take much time.
Okay.
Right. So we might think it is, but also recall that we are not transcoding the entire video file in one shot. We're just transcoding it chunk by chunk.
So storing to S3, but it can't be done everything together, like pushing it to CDN and S3. It's because it's real time. So we are putting
it it would still go via CDN because that's where the request came from. It would go via CDN. It's not that it won't go via CDN. It would still go via CDN, but the transcoding that would happen on demand.
Okay. So another question was like quite like it's where I don't know much, so I'm just asking. So if we are doing through browser, so user doesn't know, like let's say he uploads the video. So you said for S3 storage, basically it will be stored in S3, right? So it sends signed URL. So browser doesn't know what to do after this, right? So how will it happen? How will if it's client, then it knows what it has to do after this request. It may be in the client code, but browser, how will it do that?
No, browser would know, na. So browser got the signed URL. Browser made a call to that signed URL. The signed URL is what? It's basically a CDN signed URL. The request would go to CDN. CDN would say, I don't have the data. It would make a call to the backend. What's the backend of that URL?
I thought it's for uploading. It asked for.
This is not uploading, na. This is viewing wala part, na. No.
Okay.
because transcoding is required. So there are two ways. Like on-demand transcoding is when user is directly consuming it.
Okay.
Right.
Well, that I got it. I thought I was thinking about uploading part.
Uploading में on-demand transcoding की जरूरत नहीं है. Uploading में once the video is uploaded, then the entire transcoding का workflow would be triggered.
I mean, for upload part, it's up. User would be given link for S3 to upload, or server
user would be given link to S3 to upload. The upload would happen directly on S3.
Okay.
Right. Once the upload is done, the user would make one API call which would say publish, right? That video upload is done. I want to publish it. Once the user hits the publish, that's when the job would trigger for transcoding.
So when he does the upload, I mean, if using a browser, he is doing the upload. So he got back the S3 URL, signed URL. So it will, how will the upload happen to S3 then?
Normal file upload, HTTP call.
No, S3, because, so, okay, so it will have the URL plus signed along with that, right? So actual URL of.
Okay, what we'll do, Amrish, we'll just basically take this thing to the later half of it.
Okay,
at 10, we will do a thorough discussion.
Okay, sure.
So once we have that, to give a smoother user experience while watching the video, with a higher resolution video. So whenever user has battery, power, bitrate, internet, and all, what we would do is we would then basically fetch. We would basically keep it ready. If the user device can support that, we would stream the best resolution possible. That's what called adaptive bitrate. When the resolution is being adaptive depending on the battery power and internet speed of the user, the resolution keeps jumping up and down. Right, so that's called adaptive bit rating. So you would have to, we can build a system around it to identify what's the current capacity of the device, and depending on that, we'll make a call on that. So when the network fluctuates, we should switch between resolution and bit rates and get this thing done. So typically in video formats that you see, there is a container and a codec. We won't go into depth and details of this component. This is a very specific to FFmpeg and pura video processing stuff, might be a little out of scope for most of the people, but it's important to understand that there are two separate classes. Is like container, which is what our formatting is, and then the codec, like which is like HEVC, VP9, H.264. These are common ones. So typically how we would do is, if you'd want to do transcoding of videos, we would use a package called FFmpeg, the most common open source package out there to play around with videos and all. So use FFmpeg to transcode images into multiple formats. This is exactly what we do at Unacademy and most companies do in their production. There is no rocket science between it. So they just fire this FFmpeg command. So they download the video locally on the server's disk, and then they run this command called FFmpeg space the file name, and then what resolution do you want the video in and what stuff. It takes all of those things as command line arguments, and then it fires that command. It would create output of another file, and it would, once that command is successful, the file is then uploaded to S3 again. And this is the raw way to do it. And there is literally no other way. Like everyone does exactly this. It's just that some might be using language bindings of FFmpeg. Someone would be calling the shell script of or the shell command of FFmpeg. But at the end, everyone would somehow use FFmpeg or basically any similar packet. But most commonly, 99% of companies use FFmpeg, which is a great utility. Even I'm doing that to do transcoding and stuff. So this is something that would happen. So the flow is, whenever the video is getting uploaded, some server, you download the video, you would run this FFmpeg on it and create multiple formats and resolutions on it, and then upload back to S3 saying, okay, these are the versions which are available for someone to use. So once the client understands it, so this is okay. So here, what would come into the picture? Like, because now what we want to do it is, once the video upload is done or when the video is published, right, then I have to trigger transcoding, right? Or when the video is uploaded, I want to trigger transcoding. So when the raw video is uploaded, my API would know that my raw video upload is done because my client would tell it. Now it would do what? If here our event backbone comes into picture again, Kafka, because it's an event driven architecture. So API server would send an event in Kafka saying that for this video ID, raw upload is done, trigger transcoding. So then this job would be triggered, then this event would be consumed by your transcoding thing, and it would create a, then it would have to run a workflow, right? So typically what we use to do this is something called as a workflow management tool. Like basically, if you have heard of Airflow or AWS step functions, this is exactly that. Based on directed acyclic graph, here each node of this, so it might be same server or different server. So each node of this graph, okay, each node of this graph is one processing unit. Okay, each node of this graph is one processing unit, and once the processing of that unit is done, it would go to the next step. Now let's say this is the first processing unit. Let's say this step says download the video. Once the video is downloaded, it would trigger 3 jobs, 1, 2, and 3. It would trigger 3 jobs here, and these 3 jobs would run in parallel. Okay, once this job is done, it would trigger this job. Once this job is done, it would trigger this job, right? So these are all independent computations, right? No one is dependent on anyone. You can add dependency key. Once this is done, then do something else. But if you want to have an architecture like this, you can obviously have it. It's just like a normal graph that you can have. After this, do this. After this, do this, right? And there is no backlink. That's why it is called as directed acyclic graph. It can only flow in one direction. Okay. Now, where does this come in handy? So, okay. First of all, 3 good implementations of this: Apache Airflow, AWS Step Functions, and Spotify's Luigi. These 3 are most popular ones. Apache Airflow is by far the most popular one out there. These are workflow management tools. You can have conditional branching at most, and this system typically has its own database to maintain key. Which step has it already done? Now this step is done, go here. Now once it goes here at this step, what needs to be done? It would be maintaining, okay, this is the code that needs to be executed, and then it would execute the code. So for each processing node, there would be a processing code which is written. It is, you know, you'd have language bindings for like Java, Python, and all. You just write the code in that language. You would like, for this thing, for this node, you can use this particular function call. So there is a way through which you would use decorators to map and point key. This function should be used as part of this decorator. And then that particular function call would happen. And the input and output of the processing would be defined on the previous function which is called. And all of this happened through a common database of Apache Airflow or whatever you're using. It happens through a common database out there. Right. A great use case. Just Amrish, let me just cover a few things. We'll take up questions at the end. Okay. So DAG use cases, like we would use it at any place where you would need workflow. I'll give you examples. Okay. Video processing workflow is what we're discussing right now. Think about employee onboarding. Let's say when my employee is onboarded, like let's say a new employee joins an organization. I want to create an email account, Slack account, maybe post a message on Slack, right? I want to do these 3 things. Once the email is created, I want to send him or her the welcome email, right? If this is like a typical workflow, like once a certain event happens, do ABC. Once that happens, do PQR and something like that, right? So employee onboarding workflow, this is something that we can, you know, trigger out of it. At every step, you would have this one function call that would happen, that once my processing reaches that node, this is the function that I would be executing, right? Another thing is, let's say with the Instagram example that we saw, once the photo is uploaded, like do a plethora of things, like extract tags out of it, index it into a search, check for nudity and profanity in the picture if needed, then do some quality checks, like if this photo was of good quality or not, or something like that. Like if you want to do, once the photo is uploaded, you want to trigger a bunch of jobs, right? So here what we are actually doing, if you see, since every single node is running in parallel, we are getting a very high parallel computation out of it, right? Making our systems high throughput. So when one video is uploaded, it's okay. But when one video is uploaded every minute, and if that video on an average is of 1 GB, you would have to have a lot of computation power. one machine or a small bunch of machines won't be able to sustain it because it is a CPU intensive process. So you need multi-core machines and multiple machines like that to handle the load. Now, when these many things are handled in parallel, things become very messy. What is happening, where it becomes harder to keep a check on the things that are happening. So that is where workflow management systems come into the picture, where they help us basically visualize the workflow, and it's job of that system to ensure that one happens, it would trigger the child jobs, and then one of them happens, it would trigger the child of that, and every single thing happens in parallel. And it's just that this is the dependency that once this is done, the child would happen in parallel, right? So this is a great examples of like DAG use cases. You can dive into Apache Airflow, and I would heavily recommend you to like implement a hello world using Apache Airflow to get a very detailed understanding of it. And you'll see that how many things you can build out of it. With respect to transcoding, so transcoding is computationally very expensive. Not just expensive, it is very expensive. With respect to Unacademy, I don't know how much money we burn in transcoding. We burn quite a bit of money. Like there are so many machines running, and if it was not with Apache Airflow, like see with Unacademy, every minute on an average we have 1.5 classes live happening, and so we do on-demand transcoding for our learners to consume. Once the class is done, and we have the recording, we do transcoding of recordings as well. We have so many machines running just to handle those many video classes happening concurrently. That does so much of transcoding in on runtime, and once the recording is uploaded. So we have like 300 odd machines, massive machines, just to run this transcoding and stuff. Like, these are computationally very expensive and very time consuming, and and you can add, and the best part of it is you can add as many branches. So tomorrow, if you'd want to add one more thing in parallel, let's say once the video is uploaded, apart from doing all of those things that YouTube does, let's say what I want to do it is I want to find the best thumbnail out of the video. Let's say there is an algorithm that you would want to trigger that once the video is there, I want to find three possible thumbnails out of the video. Like maybe some algorithm that identifies all the frames or that analyzes all the frames and finds the best ones. Right? If you can add one more thing without even changing the flow of others, right? So that gives us it. And obviously, all of this thing can also be done through event-driven architecture. I'm not saying no to that. Workflow management tool is something that is a new Lego block that you should be knowing. And there are some ways through which it becomes easier for us to visualize it. So it boosts developer productivity by a lot, because event driven is also going to be in parallel. This is also going to be in parallel. So there is not much cost wise benefit, but it is a very nice aesthetic. It gives me a visual way to see and manage my workforce. Okay. So most cases, this high parallelism, because when something is CPU intensive, you need high parallelism. You need multiple CPU cores, and there's a limit on number of CPU cores you can have on one machine. So you'll have plethora of machines at your disposal. So the streaming, whatever you do, whenever you need high, whenever you're playing with high computationally expensive process, and if it is something that can be transformed into a workflow, go for a solution like this. You'd be very happy implementing it. What Facebook does is whenever you upload a video on Facebook, this is what I got from Facebook's blog. When you upload a video on Facebook, they use a similar workflow management system, Apache Airflow like system. And once the video is uploaded, they do audio processing. So to make audio much clearer, and then they do video processing. And video processing, they do everything that I explained in the last thing. They trigger watermarks and whatnot, like all of those parts. So something similar to this. So video processing what happens is it does a basic validation check. Once the video passes a validation, it does transcoding. Transcoding it would create multiple formats, multiple resolutions, each one of them being its separate child. It would do the copyright checks. This is a new thing that come up. Like once a video is uploaded, you have to check for copyright issues with music and whatnot, because YouTube, if you see, whenever there's a copyright issue, it basically mutes the video. It basically mutes during that time. So let's say T series ka koi gana use kiya hai, and if it is used in some show or something, it would mute that particular part. That happens automatically through an algorithm. There is not basically the channel owner is not going and muting that part. It is the YouTube who is muting it because of copyright issues. then thumbnail generation, then captioning, like auto captioning, like machine learning wale workflow that does video ko audio processing and does auto captioning on that, right? And all of these things, there is one database, like each service might have its own database on which you are making an update. So just like updating all of those things in one database if required, right? So this is a typical process of how like DAGs are helpful, right? Now, when it comes to transcoding, like here transcoding was just one dabba, but transcoding can be child processor, like generate 360p, 480p, 720p, 1080 with multiple. We saw about multiple codecs in multiple containers. So not just 360p, but 360p in a certain format, 480p in a certain format, right? And with a certain codec, because some devices might support that, some devices might not support that. So there are so many things that needs to happen whenever whenever a video is uploaded. So you'll take care of all of those things. Once all of these videos are generated, they are uploaded back through S3, because from there only our CDN would pick it and would stream the video, right? So once this is done, all of these things are uploaded to S3 and then they are put there. Now, next part is obviously faster uploads. We all have been talking about chunking, so on and so forth, right? We can make upload faster. So this is what happens behind the scenes. So to make upload faster, most time consuming thing, because like, let's say you have 1 GB worth of video, and what if at 99% your internet got disconnected, right? Or your internet went off, or your upload failed due to any reason. Would you re-upload 1 GB again? Like it's a very bad user experience. So that's where what typically happens is you make your client smarter. Whatever the input file is, you break it down into chunks and then you upload it, right? So then the upload flow changes a little bit, because you can't just have a signed URL on S3 where you're uploading the entire file, because now your client needs to understand, your server needs to understand. So there is a very different way to design that system. You can explore it, and it's not that hard. How to you chunk and upload it? It's very easy. You can either go via API server or directly upload it to S3 by using chunking facility on your blob storage. Like not just S3, but any blob storage supports chunks, basically chunk based streaming uploads. So you can leverage that. So the idea with multi-part uploads is what would come in very handy here. So multi-part upload, what happens is you reserve, let's say you have a file size of 1 GB big. So you will reserve the 1 GB space for that file on S3 or your blob storage. And then you would chunk it on your local machine and upload the chunks. You would say that, okay, this is the chunk from this offset to this offset. Go ahead and upload it on S3 on this part to this part. Right. So this is exactly how it happens. So I've been working on this part as an optimization at Amazon when we were working with database. This is what I exactly did. So we used to reserve, so each file was like 15 GB big. We used to reserve a space on S3 for that 15 GB for that file. We used to create that file with 15 GB of space. On the client side, we used to chunk it, and we had like we had configuration of how many threads we have to run it in parallel. So we used to configure it at 16 threads in parallel, because we had about 8 core of machine. We had other processes running as well. So 16 threads were running at that time. Each thread was running, like each thread was responsible for 16th from its offset, 16th chunk from its offset. So 0, 16, 32, 48, 64, then 117 plus 16 plus 16 wala, वैसे चलते जाएगा. Right, so each one was uploading that one chunk of video onto S3 directly. So this is how we got faster uploads onto S3. So this is exactly how, like, not just blob storage, not just functionality of S3, but even if you want to do it on a local file system or network attached file system, this is exactly what you do. You create a big file of 1 GB big storage having all zeros set in it, and then you just update that particular part once you are uploading that chunk. When upload in a chunk is implying that from this offset to this offset, replace it with this content. That's what you do, right? So chunking is something that you would leverage there. Then comes another part is around security, like encryption of videos at rest on the fly, DRM, like the way to protect videos to not, get streamed, to protect against piracy. Then post-processing using watermarks and all on the video. Then you would always have CDN in the front of a blob storage to stream the video back, and the digital signature workflow remains as is. Okay. Now, CDNs are costly. YouTube's ka another problem is, number one, you can't do a transcoding of all the videos which are uploaded, right? So you would be having a system or some engine that would tell you that does this video need to be transcoded, right? For example, if BBK Vines upload a video, it definitely needs to be transcoded because it would be viewed by millions, right? But if Arpit uploads a video, YouTube won't care. कितने लोग देख रहे हैं? 200 लोग. I'm not transcoding. I'm not wasting super expensive CPU on transcoding Arpit's video, right? I'll do it on demand transcoding for Arpit's video. If I see good enough traction, then I will choose to do a detailed transcoding of Arpit's video and just basically keep it ready, right? Why this makes sense? Because in most cases, the views on a video are long tailed, right? So you would have, like, once the video is uploaded, there would be a massive spike on that video. This is all in comparison. Like BB might have a very high spike, Arpit might have a big spike because Arpit have very recently shared it on LinkedIn and Twitter and Facebook. So thoda spike aa gaya, but then it is a very long tail. So you would cache videos and you would choose to transcode videos if it's a very high reach and your on-demand cost would go very high. So, and obviously caching videos, you would cache the videos and on the CDN immediately when they're uploaded, when it is in this phase, right? And then basically deleting it and basically moving it out of the CDN because it is not really required. Like, because CDNs are costly, it is charged on the basis of kitna access hota hai and kitna store kiya hai, right? Both are the metrics on which it is charged. So you'd have to keep that in mind. So you would understand, you'd analyze the patterns of the video, and then number one, choose to transcode or not. Number two, choose to cache it on CDN or not, right? Depending on the kind of user you have, the kind of buckets, the kind of popularity that the video might get, you would be putting it there. Okay, so yeah, this is something that you would always need to think about whenever you're designing YouTube. Like there has to be this decider, like this thing. There has to be, so whenever a video is published or on view, these events are analyzed by CDN decider, whose job would be for a video or for a upload, whenever a video is published, decide, do I want to cache it on CDN or not? Right? Do I want to proactively cache it on CDN or not? So why on published? Because, like, let's say BBK Vines uploaded a video, definitely on CDN. Let's say if someone, let's say one video is getting too much this interaction. Let's say how Yashraj Mukhate ka Rasode mein kaun tha video went viral. He never got more than 10,000 views on his video, but that video went viral. Once your system starts to find that, okay, this video is going viral, I'm seeing unexpected number of views and a lot of people are sharing it, this events will be analyzed by CDN decider and it would immediately start to cache it, so that when other people commit, it does not have, so the video immediately starts playing, right? So this is another thing that you would need in the system to make your entire system efficient. Like, it's just about making the best use of your resources. You don't want to over cache things on CDN, right? Because cost aega. You don't want to over process things on your computation by transcoding it because cost aega. So in most cases, cost is like such a big factor, and especially when you operate at scale, right? So you'd have to understand the access pattern, understand virality of the video, maybe future prediction that if this video can go viral, you can do that. And if this video is published by a star or an influencer channel, that would be cached. Okay, so then similar to this, this is the final slide of YouTube. You would need another service like trending service, which would, define the trending page of the YouTube. So it would have its input, like it would go through like on view. Every single view that happens on every single video, it would be gone to this trending service, whose job would be to find out if this video is indeed a trending worthy video. If it is, it would add it to the trending page. It would obviously cache it and then add it to the trending page. So this is where what I've added is I've added one more event called cache it. So this cache it, when it comes to the CDN decider, it would like immediately return true. So if my trending service, because once I have decided to add a video to trending, I definitely want it to be cached, right? So if I'm explicitly want a video to be cached, how can I leverage my existing workflow? So I can just create another event called cache it, And if the video ID that is passed on to it, the CDN decider would use that video ID and immediately put it onto the CDN. Right. So this is how like you can have the communication between two services using event bus. Right. A trending service will identify if the video is trending or not. It consumes on view event from the bus, like every single view is assumed, and then it would like put it into this thing. This is very similar to designing the trending page of Instagram. Like, how would you do that? Okay. A lot of abstract discussions here, but you know, when you build systems at this scale, if I would have dissected into each one of these components, it would have taken far too long because you know every single component is too complex here. I've just tried to keep it a little abstract but a little detailed as well. Okay. Yes, Sanjay?
One product question on views that you mentioned. Like YouTube, people can monetize on based on the views, right? So
yes.
Now, if CDN caches it, you don't want the hits on the storage server, right? So you want the actual number of people who are watching the video, right? So then the analytics has to be done on the client side rather. Or that
No. Analytics still happen in server side. See, it's not that videos are made public through CDN. Like anyone having the CDN key can hit it. The request would still go to API server. API server will still generate the signed URL, which would then go to the CDN to get it.
Okay. From the API server, then you need
API server से एक request API server पे जाएगी. Like even if it's not like video view, right? It could be as simple as like how I'll tell you how we did it, right? So what we did was whenever you open the page of that video, let's say a lessons page, when we opened, there would be one API call that would go like get lesson. Correct. That event would come in like get lesson card detail page something. So whenever that happens, there is a chance that user will play the video, right? So that is a server side event. Another thing that we capture is on the client side, we capture what all user has pressed. So on the player that we have, when someone plays the video, we capture one event from the client side, which streams to the server side and gets stored into our data warehouse. Okay. Then upon every 15 minutes till the video is being played, we send one event not 15 minutes, 15 seconds. Once every 15 seconds, we send one more event to the backend server that would say that, okay, this guy or this person is watching this video and it has been 15 seconds, 30 seconds, 45 seconds, like so on and so forth. It would continuously keep on sending events to the backend system that we have. And all of these events are stored. So it is typically amalgamation of two things, backend events and front-end events, right? So backend side say events or the API side events might not give you a very high user relevance to it or user behavior of the situation. But when you are measuring it on the client side, it would give you very exact things that how user is actually interacting with the system. So there are some events which you or for which you would rely on the client side events that streams to your backend server, and there are some events that you would rely on your backend server itself. Another example of backend server or basically backend system based events would be how many times a video was decided to move to CDN. Like that is an example of your server side event that you would want to like basically server side analytics that you would want to measure.
Okay, and this is possible because Unacademy builds its own player and adds it on the.
Yeah, exactly. Exactly. If it is not there, you can just hit if the page is listed, you can just assume that someone has done it. But yeah, typically it's just otherwise the video players that you have, they have events on it. Like on the JavaScript side, whenever a button press is there, most of the good implementation of video players, they have events on it. Like whenever any button is pressed, you'd get an event called button pressed and you'd get a button name out of it. So then you can use that to, stream those things to backend.
Okay, thanks.
Yeah, Anshuman?
By event bus, did you mean Kafka or?
Kafka.
Okay.
We already discussed with Instagram, no? But same thing. Right. Because there might be other consumers. Like if you see on view event was not only used by trending service, but is also used by CDN decider. If I would have done it on a message broker like SQS, then replicated message भेजने पड़ते थे, या rather duplicated message भेजने पड़ते थे. Okay. So that's why Kafka. Okay. Yeah, Amrish.
So actually, since we have a client for this, so client can you can configure as per the need. Client can send the events. Does somebody watches this Unacademy videos on browser? Then you can't have control, right? Browser.
Yeah, why can't? Why can't?
How can then browser won't send you event, right?
I can configure. I can always listen on to JavaScript events that are being configured on the system, na? Like this is exactly what I spoke about right now. What do we have is whenever some button is pressed, I can have an on-click lister and I can send an event to backend.
Okay, so even with the browser, we can have.
Yeah. And then it's just JavaScript. Yes. So long as JavaScript is enabled, I can have all sorts of fancy events I want.
Okay, so whatever activity even browser happens.
Exactly. That's how Google Analytics work. Google Analytics, Mixpanel, Amplitude, they work on this very thing.
Okay, so all activities on the browser, there's some event going on to the server. Server is doing that.
Just open network tab, open YouTube, open network tab, play a video and see the kind of events that it streams.
Okay.
You'd stop using YouTube.
Okay, so second thing, airflow, right? So event driven is fine. So instead of because we need some kind of DAG, so we can would have used like Kafka pipeline.
That's event driven. See, you can either do event driven or you can do DAG.
Okay.
DAG gives you that advantage where it gives you that aesthetic. Ki acha dikh raha hai. You can visualize your workflow. You can add new nodes into your workflow very easily. With Kafka, it is not that simple, right? So basically, it's just an abstraction on top of it.
So how does it internally it manages the airflow? I mean,
उसका एक database होता है where it says that this job ran every instance, like when the video is uploaded, when the workflow is running, every initiation of a workflow is a new entry in its database. And then it would keep tracking. Now this is the new instance of my workflow. It is there in this node. Let's say I'll go to this node only. So it would have this thing on the database where it would say that now I'm here. Now this is the new, now let's say video upload is happened and I initiated this workflow. So once I initiated the workflow, it would create a new instance, give it an ID. So it would say that workflow ID W1 is right now executing this. Once the execution is done, it would update the database and say ki workflow ID node N1 is done processing. So now it would trigger this, and this in parallel.
Okay.
Right. So because it would have worker nodes.
This processing is distributed to different machines.
This is distributed to, so basically the architecture is simple. There is master node, there are worker nodes.
Okay.
Depending on how many worker nodes you have, each execution would be scheduled on that.
Oh, it does all those things internally.
Yeah. So you would need to configure ki I have an Airflow setup with one master and 200 workers.
Okay.
It would do ki this job needs to be scheduled on this worker. And so basically it would communicate through queues. It would put it into a queue and then queue would pick up.
Oh, okay.
And then
so it's kind of internally working as a scheduler kind of.
Yeah, it basically this is what I do. एक level ऊपर का जाता है, it just gives you this nice aesthetic कि तुम देख सको कर सको. That's it.
But underlying it would be very complicated, right?
Not that complicated. It's very easy to build.
I mean, implement Airflow kind of thing.
No, Airflow implementation is very easy, not that hard. Because at the end, it's just about events that you send to the queue and someone consuming it. But basically, sending event to the queue and consuming it is abstracted from us.
Okay.
Right? Because all we write code is we write code for this node, this node, this node, this node. We don't worry about how the communication between these two is happening.
Yeah.
Right. So it has just abstracted those things out.
Yeah. If I try mimicking it through Kafka, I will run consumers on all
exactly.
Other nodes. Keep on
वही है, बस वो abstract करके रखा है.
Okay.
Yeah, Kaustuv?
Just a bit confused. So does Airflow also do like scheduling and other such things?
You can run scheduled jobs on Airflow. Airflow supports
scheduling as in which, like, I'll just say job. So which node to run it on and things like that, or do we have to handle that?
You can define. So by the way, by default, it is like all nodes are equal. All the nodes are equal. Any node can pick up any job to execute. Right. It would just say ki this is one initiation of my workflow, and now it is at a certain step. Let's say this is basically let's say this is that step. Now, once this step is executed, I have 3 things to run. So it would add 3 messages to the queues.
Okay.
Which will be consumed by, like, let's say there are 200 workers, and everyone is polling onto the queue ki koi kaam aaya to de do. Right? It would say that they would pick up things, and then since 3 work, and then basically if it's just single threaded process, then your 3 things would be executed on 3 different machines.
Yep. Makes sense.
Ekdam simple. Matlab, you can build your own airflow like a very basic version of airflow within a day. And it's a very fun exercise to do it. Like, you just need one message broker to build a system. It's just about how efficiently are you able to track the start and the end of a certain node. Is the process or the execution of this node started and ended. So now I have to trigger this. So basically storing this kind of DAG information in your database and keeping track of what happened when is what the magic is.
So internally it uses some DB, right?
Yeah.
So how does I mean, if it's too much sharded and all, so these processing units, how will they direct to that shard if it's sharded?
नहीं, वो उनका काम है ना, उनका देखने का क्या है.
Airflow
how are they storing? But it's not our database, na.
Okay.
The database here in picture is the Airflow's database.
Oh, okay.
To store that information. So it is responsibility of Airflow. But our database, it's our business logic, then we'd have to take care of it.
Is there any document to read about? It looks very fascinating.
Apache Airflow, Google Apache Airflow, you'll find a very nice detailed stuff about it. Yeah, Prabhat?
Just like to add something here, Arpit, like we also can have like dynamic worker nodes. For example, if we are using Kubernetes and Docker, then we can have individual images for certain kind of workloads. And then at runtime, we can make that kind of node and run that process in the workflow. So like there are 2 ways to like basically run this Airflow. One is like maintaining static workers and Celery with the help of Celery, and other is basically for by using Kubernetes and Docker. So it provides basically some dynamic environment to execute.
Thanks for bringing that up. Thank you so much for bringing that up. We are exactly doing that. Just didn't want to make things complicated, but now that we are on that topic, the great point that was being brought is what I told was that we have like fixed set of workers and stuff, right? But if you see, like, we are assuming that all workers have the same set of machine. Now, here we are talking about like virtual servers. What if we have a containerized environment? If you have a containerized environment, we can also specify that run this node with this base image and this execution code. So you can on the fly add containers to it, run custom, basically run it on that custom container. Let's say, for example, if you are building something like a browser stack, right? Browser stack is a great example where you would want to run testing for multiple OSs. Like, so basically multiple operating systems. You want to test your application on multiple operating systems. Okay, so then you would have like your machine is just Ubuntu machine. Like, how can you run Windows? How can you run iOS or basically macOS on it to basically test something on it? Right? If that is a use case, then you need a totally different and virtualized environment to run your job there. Right? So for that, you basically don't need static set of workers. What you'd need is dynamic workers, which are basically dynamic containers or dynamic servers, which are spun up on request with a configured base image. And in some cases, the base image would be Ubuntu. For some, it would be Windows. For some, it would be Mac. This is just an example to, if you're building a similar system like this. So that's another level of abstraction. So instead of going for static workers, you can always go for dynamic set of workers where the base image itself changes. Thanks for bringing that up.
And like another thing, like I would like to add is like we can also have sensors in our decks where like the sensor can monitor a particular S3 bucket for an additional video that comes up, and then the deck can automatically run for that.
So is it like your webhooks, when S3 has something, a new object uploaded, do something?
Yeah, so there will be
webhooks.
Yeah, so so decks can have like one deck can have a single task, that like a root task, like continuously looking for something new in S3. So
okay.
and then once it comes up, like it sees something new, then it can allow the workflow in the downstream task to run for that thing.
Okay, interesting. So I typically do this with webhooks. So S3 lifecycle hooks. So whenever a new file is added, instead of me polling S3 and telling it, I can configure lifecycle hooks on S3. But I'll say that whenever a new object is added, trigger this Lambda function. And what I do is in Lambda function, I write trigger this Airflow job.
Like it's less resource consuming using.
तो मतलब वो जब upload होगा तभी वो trigger होगा, rather than me continuously running a process who is checking on S3 if anything new is created. And this is again extensible to something like if you are building a Travis CI kind of thing, which would work on GitHub. Let's say even bigger than that. Let's say you're building your own CI/CD. You're building your own CI/CD. Anytime something is merged in master, I want to trigger a deployment. Right? If you see this DAG is nothing but like a deployment workflow. Like when I say deployment, I want to run database migrations. I want to create a parallel infrastructure. Then I want to pull the latest code and do something around that. Right. So now what I can do is whenever something is merged into the master, I want to trigger this job. Now, how would I find if something is merged into the master? Either I can check, I can poll and see if my commit ID changed or not on master. If it did, then I trigger it. Versus GitHub gives me webhooks. So I can configure that whenever something is merged into the master, GitHub, please call this URL. So GitHub invokes that URL, and that URL ke handler mein I write ki trigger an Airflow job about deployment stuff. Right. So if you're one of them to design a Travis CI or your own CI/CD sort of stuff, you can use this kind of thing to build that.
So even triggering that event, you should have some queuing mechanism to do that, right?
Triggering that event typically, yeah. So वहाँ पे भी queue होगा. So when that event happens, it's part of their code base to trigger all the configured webhook URLs, and that happens through queue.
Okay, so basically they would have kept this mapping for this event. This here it has you have to send the event. Okay.
Yes. Nice. So, any other questions?
Regarding live streaming, will we still use Apache Airflow or do we gonna use any other?
Live streaming Apache Airflow has no relation. So it's all about transcoding. So once the video is done, like once the video is recorded, and then we have to transcode it and keep it for other formats. For live streaming, it is on-demand transcoding. Okay, so वहाँ पे Apache Airflow can't come into the picture.
So are we gonna do chunk-wise or like how it's gonna?
It's always chunk-wise. It's always chunk-wise. So because that's how you'll get parallelism and faster thing. Right? So you'll always break it into chunks and then do it. But day zero implementation would be download the entire video file, run FFmpeg on top of it, and do it. Otherwise, you can split it into chunks and then run it.
But live stream we can't download the complete one, right? It will be.
No, live stream, but it will always be chunks and on demand. It has to be on chunks because you don't have the entire video with live stream. So one reason why Hotstar, when it started streaming out, you always had this 5 minutes of buffer, right? So basically 5 minutes of lag. Right? So Hotstar ke case mein, that 5 minutes of lag came from where? It required that the match that is happening live, it required some time to do on-demand transcoding and processing and putting it on CDN for others to consume. That's why that lag comes into the picture. And mostly when they say that the match is shown live, the stadium pe kuch aur chalte rehta hai. Stadium pe like if you've seen the series called Inside Edge on Amazon Prime, the first season of it, uspe they told this thing ki the time when the match is shown on the television, and the toss that happens on basically they were betting on ki who would win the toss and uspe se paisa double kar rahe the. So the bookies always sit in the stadium because that is the actual live thing that is happening. If someone is relying on the TV to place the bet, तो वहां पे ना पूरा चेंज हो जाता है because the toss has happened and till the time it is being sent onto the TV, it might take a couple of minutes ka lag. With live streaming, it might be like 5 minutes ka lag. Just some random time ka example, but yeah, obviously this time adds up because someone has to do processing and then streaming and then it being sent to the user. So वहां पे they used to place this bet by being in the stadium and then basically manipulating the betting market. ऐसे क्या examples होते हैं क्या? ठीक है क्या अंशुमन?
Yeah, so I was wondering if all this video transfer takes over UDP, right, or TCP?
We started with TCP, then we moved to UDP. So because UDP, even if there is a packet loss, it won't make a lot of difference.
Okay, but right now Unacademy is using UDP.
UDP, yeah.
Okay.
We were naive to start with TCP, and then we moved on to UDP.
Okay, well, I mean, what are the reasons? I mean, I know one.
पता ही नहीं था ना तभी कि UDP से better performance आ सकती है, तब चमका ही नहीं ना. Because the kind of tutorials we found on the internet, they all use WebSockets to stream the data. WebSockets is TCP.
Right. Raw TCP.
वहीं पर problem हो रहा है because we did Google search. Google search पे पहला आया WebSockets से live streaming. We implemented that. That's the problem. No, we never thought, because obviously we didn't know that the product was going to last. वो तो अभी भी पता चला कि company is going to last for at least 10 years from now. तो फिर अभी engineering लगाएंगे. Yeah, Amrish.
So is this the same case which you said about getting data? Like if you watch stock prices on Yahoo and Google, it's not always same. It's a bit different. Like
हो सकता है. I have no idea about that stock वाला difference क्यों आता है. But for live stream वाला तो I can definitely see क्यों आता है. तो stock के बारे में no idea. क्या विशाल?
Yeah, so for video calls, also same thing happens, right? Transcoding.
On demand transcoding. Typically this is all on demand transcoding. But वो बहुत cheap transcoding होती है. मतलब it's usually, if you see, that's why all these apps like Microsoft Teams, Zoom, they prompt you more to use their app versus to use the browser pay streaming, right? Because when you use it on browser ka streaming, you don't know the kind of device that is there, or the kind of the kind of things or the kind of encodings that the device would support or the browser would support. But with the app, they can actually patch the encoding which would work the best. Right, so they would exactly know, okay, I just have to worry about like this codec and this transferring, so uttai transfer karke I'll send. मतलब वो सब ये सब product decisions और engineering decisions होते हैं यार. मतलब वो बस होता है कि if you see that play this on browser is a very small text which is hyperlinked, इतना छोटा सा करके रखते हैं वो, so that you can't find it and you download the app.
One thing with video calls is that most of the objects don't move. It's only your mouth that's moving most. But it's like the movement is much different, like compared to, let's say, cricket match. Like on a video call, if you shake your phone and try to bring in a lot of colors, you can immediately see the quality decrease.
Yes. Mostly it's all about the kind of use cases that you're solving. You can have a lot of local optimizations for that. Like for video thing, I'm not going to move like so quickly. Like it would happen like once a while, but not happen every time. But with cricket match, you can't do that. So depending on the kind of use case you are solving, you would have some local optimizations that will play a major part.
Yeah, but if the movement is fast, why would the video will be distorted?
क्योंकि image compression basically video compress होके भेजता है. So when there are frames, like for example, have you read about the run length encoding?
No.
एक बार पढ़ लेना run length encoding के बारे में. You'll एक झटके में understand what I mean by that. Because the way video is compressed ना, if there are lots of fluctuations between the consecutive frames, right, versus if the consecutive frames में there is a very little fluctuation, तो बहुत छोटा data pass होता है. तो उतना कम टाइम लगता है ट्रांसफर होने को, उतना कम टाइम लगता है प्रोसेस होने को, उतना कम टाइम लगता है सेंड होने को, उतना कम टाइम लगता है रिसीव होने को, उतना जल्दी देखा जाता है.
Okay. Got it. I'll read on run length.
Yeah. एक बार बस run length encoding पे देखना. Mostly example would be integer based, but you can very easily correlate कि क्या होता होगा. तो वो बहुत मस्त है, मजा आएगा.
So basically tutorial videos, there won't be much changes, right? Rather than live videos.
Screencast are the most efficient ones out there.
Yeah.
क्योंकि एक लाइन ही चेंज होती है.
Right.
So if you see that screencast page, it's very easy to get a very good quality even for a 480p video.
Okay,
But when a person is talking live, 480p video seems like shit.
So do you encode audio and video separately? I don't know how.
Separate.
Okay. So how does this map with the video and audio together? I mean,
overlapping one over other. Simple ना कुछ तो नहीं है उसमें.
no, sometimes it happens, right? So somebody is speaking something and video is something else.
नहीं वैसा नहीं होगा ना, because we have like audio stream and video stream captured from the same device at the same time. It's just about we getting all the data together and then patching it one over other.
Okay.
Next. Chalo. It was really fun discussion. Next week, we'll be discussing about IR systems, information retrieval. We'll go through TF-IDF, internals of search engine, few recommendation problem. अब थोड़ा सा मैथ चालू होगा. Not much, definitely not much. But इतना कि that is essential for any software engineer, any computer science engineer to know about it. उतना मैथ्स कल का and the final week थोड़ा सा मैथ्स रहेगा. Because but basically that is essential for anyone to solve that problem. Otherwise वो problem solve नहीं होगी recommendation की and retrieval की. Okay. Yeah, Bhupen.
Yeah, with a small question, I have used FFmpg or terminal and using a client in a hackathon. So that's like it's quite simple. You give the file as the argument and things work. It's very powerful. But how would you do it like live streaming? Can you just give a little more
on
detail?
live streaming? We can't use FFmpg.
Okay,
Live streaming
so
we can't use FFmpg. So there is something called as Janus, JANUS. Google that.
JANUS.
Yes, JANUS. Google that. Second, Google about VP9. Okay. Third thing, Google about turn servers. TURN servers.
Yeah. Turn server, yeah, that I know. Like,
वहीं से हो जाता है, पूरा जादू वहीं पे है. Basically, WebRTC के ऊपर you can stream, you can use VP9, HVAC we also use. We tried up a lot of stuff to get performance out of it.
So that like this turn server and all, they are like for streaming the same exact quality,
yes.
Or is it
yes.
like
So beach में
how do you transport
you
to different device?
So beach में we typically transfer. So we don't. So that's why in this case we have a restriction if we only work on Chrome. Firefox it staggers a little bit.
Okay, so what about Chrome and Android device? Like
browser? Yeah, we do that. We don't support all the devices.
Okay. But you support a mobile device, right?
Yeah, but mobile baby, Android is like 90% and but other is iOS. In that case, they are not opening up on browsers. They're opening on in mobile app on the native web view. Web view is Chromium for Android. And for iOS, it is Chromium based. So chal jata.
Okay. That's a good habit.
So if we find people who are using something, that something happened with Samsung phones, which didn't have a Chromium based browser. So wahan pe we saw that problem. And wahan pe then what we did was we asked them to, open it on browser because we were too young. And now we just show them the message ki open this thing in a Chrome browser. Why should we even implement? Because like it's just like 0.001% of people like unke liye to na optimize karte. We are not YouTube to optimize for that.
Yeah.
See, those are
so
calls
the
that
same
have
stream
to
for
be
so the same stream for, let's just say, on a desktop you would have a reliable network connection. On mobile you won't have. So you have the same kind of bandwidth stream on both of these.
Right now we do. Right now we don't do any kind of differentiation there. But 98% of people watch live classes on desktop because that's what their use case is and they want to study.
Correct.
So while they're studying, they will have notes and tables and all of the setup. No one is studying live on mobile. On mobile, consumption is mostly recorded. So that is where our transcoding wala thing kicks in, right? So it's just about, so we could do on-demand transcoding, but do we need to? No, right? Because our user behavior is learning live happens on desktop because 99 point something, basically 98 point something % people are watching live videos on desktop. तो फिर उसी पे करना
I see 98%. I was not sure. I was like students,
हमारे केस में
98% of
होता है
students having a laptop is I don't know. I never thought कि ये
हमारे
possible
केस में
है.
मतलब we were also shocked to find it, but हमारे केस में it fits true. Mobile consumption is all recorded. Live classes का consumption is all this thing, desktop.
Nice. Thanks, Arpit.
Yeah. Awesome. चलो ठीक है. We are mostly done. I'll open up this thing for questions if any. I see Ambrish still has raised hand. Ambrish, any question?
Yeah, so actually it's not related to this topic. I have a general
Monday को करे सर, Monday को करते.
Okay, ठीक. Okay.
Thanks. We anyway have a catch up on Monday.
Yeah,
तो
sure.
करते थोड़ा सा थक गया था मैं. चलो awesome. Thanks guys for joining in. We'll next week our systems, search engines, recommendations and वो सारी चीजें will pop up. In case you guys have any questions, feel free to bring that up after the class. I'm anyway thrilled to discuss them. Awesome. See you guys.
Just
Bye
a quick one. I was looking into the old uploaded documentation. You haven't uploaded the S3 architecture slides.
I did.
No,
I did. कल तो किया मैंने, नहीं किया.
I was trying to read yesterday.
I'll do that. I'll just check. I've started uploading everything on Relog. Are you checking Relog or Google Drive?
Google Drive.
तो Google Drive में week 5 में जाके देखना.
Yeah, I tried. I looked into the lost slides, but I couldn't find it.
Okay, I'll just check. ऐसा तो नहीं कि नहीं किया मैंने, कल किया. नहीं किया होगा तो anyway drop a message. मैं सब भी check करता हूँ. होगा ये उसका. ठीक है? I'll do that. Thanks for pointing it out. चलो. ठीक है. Thanks a ton guys. Bye bye.
Thanks a lot.
Thanks.